All right, welcome to another episode of StuyPulse History. Joining me this week is Seth Berg, 2009 President of Engineering and robot operator.
And
Thanks for coming on,
2010.
Seth. What's the rest of your robotics resume? You were Vice President of Engineering. Anything else?
That's funny. Before this, I went back and I read my candidacy emails. No, so I was Vice President of Engineering my sophomore year, and then President my junior and senior year.
Very cool. All right, so I thought we would start, instead of talking about the 2009 game, actually starting before the season, in the preseason, specifically talking about the off-season drivetrain that you designed and built. I believe you built it at Cox, is that correct?
Yeah, I'm trying to remember what summer I built this. I guess it was the summer before that season, but I built it at Cox, and the thing I remember was these really large machined plates on the side. I mean, it's kind of hard to see in this picture, but if I'm not mistaken, this was one of our first drivetrains that had gear shifting on it. Jody, I don't know if you got the picture I sent you, but there's like a zoomed in picture of the side plates. And I remember I thought at the time, clever things about this was that I took an Andy Mark gearbox and replaced one of the side plates with one of these plates. So it extended the gearbox into like the inner frame of the drivetrain, and then it direct drove the center wheel, if I'm not mistaken. And
yeah,
then
I believe I
connected
remember
to the
being that
two
way.
on the
Where did
outside.
you send it to me? Did you email it to me?
I think I emailed it to you.
Did you send it to my Yahoo by accident?
I don't think so.
I'll check.
No, I sent it to the right one.
Okay.
JG
But
Blay.
yeah, the interesting thing is, you did that then, and Andy Mark kits didn't do that. But now they do. Like all the Andy Mark kits do exactly what you're describing.
They like encourage people to mount it onto their own pieces.
No.
Yeah, there you go.
The kits are a plate that the gearbox mounts directly to.
Oh,
yeah,
that's cool. I didn't know that. Yeah, you can see on the two upper ones here. There's like the bolt pattern from the Andy Mark gearbox. Yeah, these were actually really hard to make because Cox didn't have a water jet, or water jet or a plasma cutter. So these were actually done on a mill. So it took a bunch of fixturing, but Cox had this like really old machinist who really seemed to not want to do work for Cox and wanted to do work for us. So he made these. Yeah, this was a fun project. I remember trying to make it really modular. So like there were these two different pretty complicated machine parts that were symmetric about the center of the printer. I work on 3D printers now, so everything is the printer. The robot, and then the rest was just 80/20 cut to length, tapped at the end. The idea being that we could like make as few big, challenging custom parts as possible. And yeah, it's funny. I had forgotten that we'd used that at the beginning of the 2007 season.
2009.
2009. Yeah, dude.
Well, I'm curious.
Old.
We didn't end up using this or designing really around it, but we used it for some projects during the season. Did you feel like as a project for you, it was like a helpful thing? How did you feel like it helped to do this kind of thing before the season?
It's a good question. I mean, I think it's an example of like trying to predict something about the game. We came off a season that was all about going really fast around a circle. And so I figured that making a drivetrain that could push and had a really powerful drivetrain was going to be valuable. So this, if I'm not mistaken, was the first robot that had gear shifting, or at least it was the first one in a while. But I was like convinced that was going to be the drivetrain we wanted the next year. And so I built this. I was like, we'll shave a week off a build season. And then of course in 2009, there was nothing to pushing. The wheels were slippery. I'm sure we'll get to this, since I'm sure
it was literally the opposite. So it's pretty funny.
Yeah, it was exactly the opposite. And so we ended up going with like a way simpler drivetrain. But I think that was, it's a good decision, right? We could have gone with this, and it would have maybe been less work, but it would have a lot more weight. It wouldn't have run as well. And so I don't know, but personally, it was. I'm trying to think back to 2008. It was one of the first things I designed on my own in CAD. So in 2008, Stephen Lamb really designed most of the robot, and I was involved, but like in a secondary capacity. And so this was really like the first robot or like full subsystem that I designed. Prior to that, I spent a lot of time. I remember when I was first teaching myself CAD, it was just like CADing things around my apartment, like lamps and tables and
Right.
things, which only gets you so far. And I also think I built my college app, so got me that a little bit.
I also think that, back then, today a lot of kids are involved in the robot design. Like there's usually a kid or two in charge of it, but every mechanism has its own person. Back then it was really just one person, like another person helped a little bit. And I remember during the 2009 season, you just like busted out the CAD. Like it was just like done in a weekend and just being like, how to do that. So I think that this project really helped you in that sense because you learned a ton from it.
Yeah, I remember. I like very vividly remember that weekend actually when I CADed that robot, because the following week, I was so sleep deprived, and I tried to find this beforehand, but I wrote this history assignment. Well, I was like, "Do you remember this?" I can't find that file, and I really want to. Where I was just like in and out of sleep, and it's nonsense. It's absolutely nonsense. I was very lucky that they didn't ask for me to turn it in that day, but I was like clearly falling asleep while writing it, and my sentences went from talking about like Cuba to talking about robotics, and I read it the next day, and I took the whole next day off because I was like, I'm too sleep deprived.
I remember reading that. It was like, I don't remember what the history topic was, but I remember it went from like serious history topic, like let's say in 1776, the founding fathers signed the 7/16 wrench, which they used in order to secure the bolt.
There have been a few times that I've thought about that, and I've tried to find that assignment. I can't find it. I don't know where it is. It's like somewhere in the annals of my email, I'd hope.
Yeah, so continuing, I think 2009 was the first year, again, before the season, we got some new blood in terms of mentors in the lab. Specifically, Dan joined the team.
Yeah.
I think he actually joined in 2008, but he didn't really get fully involved until 2009. And his help was like back then. Like now, he helps with a lot of stuff. He helps a lot with machining and building the field. But back then, he was like our main electronics mentor. And
yeah,
it's like started making a huge difference. And also there was the return of James Carpino, who I don't think a lot of people on the team know about. Do you want to take a shot at describing James Carpino?
Since Dan is still there, Dan was great, man. I remember how I always wanted to have sort of well-wired electronics that weren't a rat's nest, and it was just hard to make it actually happen. And he made that his I mean, one of many things, but like he made it happen in the 2009 robot. And the difference between that and the past was just huge, like in the ability to work on the electronics and understand them. It's funny that you mentioned James. I mean, I'm going to apologize because the seasons kind of blur together 10 or 12 years ago, but I remember that what he really wanted to do was build a base for the robot, or like multiple bases for the robot, and multiple
one was a swerve, one was a regular drivetrain.
Yeah. We still never built a swerve drive, right?
No.
As an aside, one of the guys that I work with is a first mentor, and he is designing a swerve drive, and it's hard for professional engineers to do. This guy's like 60, and it's still really hard. But yeah, and it was just like Joe Johnson. Yeah. We can talk about him later. I got nothing to do for the rest of the evening. But yeah, it was just like we I don't know, we could barely put together one robot. So the thought of putting together like multiple halves of a robot that could all fit together was like, it just seemed totally impossible. And I kind of remember like being in sort of a unhappy like battle with James Carpino that like the whole beginning of that season. But I don't know if it was kind of along a similar tangent. If I remember, it was Sakif's thing was the drop down wheel. Yeah. I really didn't. Well, it's a different story, but there's a lot of value in this game to being nimble and being able to move around quickly, because people scored on the back of you. So if somebody's scoring on you, you want to be able to move away in sort of unpredictable ways. And and also because the ground was slippery, it was hard to maneuver. And so this one guy had an idea to have a wheel that would drop down in the center and could drive you side to side because your other wheel slipped, so it was plausible.
Kind of like an 8 drive.
Yeah. And I remember, I think it was Tom. I was talking to Tom. I was like, Tom, we got to stop this. Like, Sakif is useful and he needs to be doing other things than this like cool concept we're definitely not going to implement. And I remember Tom telling me something like, you know, this is one of the painful things you have to do as a leader on the team, is like you have to be able to tell somebody that they have to stop working on something. And so I did, and it sucked. But we ended up with a like really simple, really effective drivetrain that didn't have any sort of bells or whistles, and worked really well.
Yeah, that is really tough. I think like a lot of students, I think different students handle it differently, and it's always really interesting because it happens every year. And some students shy away from stuff like that, no matter what advice you give, and some students shine through it and can like handle it beautifully. And at the end of the day, like the kid is actually like excited that they get to work on something else. Because a lot of time the kid knows it doesn't have a ton of value.
This actually comes up a lot at my job. It's like, you know, when you have a large team of people working on something, it's really hard to, you know, if everyone is their own little vector, like getting them all in alignment so that they sum together to the right thing is hard. And oftentimes like the challenge is not the engineering problem, but like all of the personal things at stake, because everyone, if you're, you know, all the good people are really invested in their designs emotionally and technically. So
actually, it's interesting that you say that. We should get into the game soon because we haven't even showed the animation yet. But through all these calls, what you just said is kind of it's a recurring theme that I wasn't really expecting to come out through all these conversations, but just the value of the interpersonal skills and the leadership skills going well beyond just technical skills. Okay, let's watch the game animation.
Man, it's been a long time since I've watched this. I'm excited.
Remember, just before, do you remember the game hint from that year? It just came back to me. Do you remember the game hint?
I mean, it was something about it was like a moon, right?
It was a moonfish.
Yeah.
And then I convinced myself it was a red herring.
I'm going to ask you to pause this in a couple places, but we'll get there.
Okay.
Welcome to the 2009 First Robotics Competition and this year's game, Lunacy. Lunacy is played on a 27 by 54 foot field known as the Crater. Alliances of 3 teams each are positioned in bases at each end of the field from where they control their robots. Additional player stations are located along the edges of the crater. The crater is covered with a slick polymer material called regolith that provides a unique surface for the robots to drive upon. Special wheels are used to
pause this for a second. Mm-hmm. I know it may be annoying, but they probably don't show what regolith actually looks like in this video, but it's used in like gas station bathrooms all over the place. And to this day, I see like cheap bathroom walls made out of this material, and it always brings me back to this game.
So I think a lot of the kids actually know what it looks like because we had the sheet of regolith in the lab until I had them being thrown out last year.
Yeah, that stuff is everywhere.
Yeah.
Sorry.
Just give me one of these when you want me to.
Useless comment. Sure.
That's okay.
A low friction interaction with the regolith. This simulates the low traction effects of driving in the 1/6 gravity on the surface of the moon. Lunacy uses 3 types of game pieces known as moon rocks, empty cells, and supercells. A trailer is attached to each robot. The trailers are the targets for the opposing alliance. The objective of the game is to get as many moon rocks and supercells into the opposing trailers as possible. At the start of the game, human players known as payload specialists are positioned in the outpost stations. Each robot is placed on their launch pad with the trailer touching the wall of the crater. Robots are able to start the game with up to 7 moon rocks in their possession. During the autonomous period, players in the corner fueling stations and the outposts attempt to launch moon rocks into moving trailers. Each robot starts in a launch pad in front of an opposing player. As robots start to move away, the other alliance may try to block the robots' progress to make them easy targets. Or, robots may use their cameras to track the vision targets on top of each trailer. This allows them to track and score in the opponent's trailers. At the end of the autonomous period, human pilots step forward to take the controls. During the tele-operated period of the game, pilots guide the robots as they attempt to launch moon rocks into the trailers of the opposing alliance. Meanwhile, human payload specialists will also attempt to score moon rocks into passing trailers. Robots can also recycle game pieces back to the payload specialists. With a low-friction playing surface, robots will slide easily and high-speed collisions will be common. Bumpers are necessary to prevent damage. The outpost payload specialists can also deliver special empty cells to their robots. The robots then deliver these empty cells to their fuel.
I just remembered something. This was the first year that bumpers were required, I think. Oh, no, the year before they were required too.
No, I thought that it was, I thought it was 2008 because that was, well, I don't know. Yeah,
you're right.
Fueling
But
station.
it was 2007 or 8.
At the fueling station, the empty cells are exchanged for supercells. During the last 20 seconds of the match, humans or robots can score bonus points by getting supercells into opposing trailers. Each scored moonrock or empty cell is worth 2 points, and each supercell is worth 15 points in the game. Good luck, and we'll see you at the competitions.
I'm remembering now, I feel like at the time this was a pretty controversial thing about this game because a lot of people didn't like this game. If you had a human player that was, which is too bad because I have such fun memories of our robot. But if you had a human player who was just good at shooting these things, you could score a lot. And if I'm not mistaken, we definitely scouted human players in this game, which I don't think we had ever done in the past. And we had it was Johnny, right?
So we had a human player for the standing position, which was Johnny. We had a human player for the position, which was Adam. Both were really good. But the thing is, Johnny was so good that we always wanted to make sure he was on the field.
Yeah.
Like he just scored every shot. Really he was insanely good.
I remember that. It felt a little
advantage.
I mean, it was like a part of a game that it really had nothing to do with your robot, which is I think why people really hated it.
Yeah, and also just like the regolith wheels is just annoying. Okay. What were your initial thoughts on the game?
I don't know. I remember not loving it at first. The whole slip, maybe it was because I had spent a bunch of time making a build platform, drivetrain. I keep using words from my job right now. It's screwing my head. Drivetrain. And I spent all this time thinking about a drivetrain that could push and go really fast because in the year before we'd gotten kind of hurt by that, and so this, it was totally different. But I do think the mechanic, and I remember thinking this at the time, the mechanic of shooting on goals that were moving around was very cool. The other problem was the balls. The game pieces were strange, right? It wasn't a ball that you could just go by, and I remember this problem where Toys R Us is, because they sold these at Toys R Us and first sold them. You want to get a lot of these game pieces so you can practice, sold out around the country. You got to think if you're the stocking team at Toys R Us, it's just like, what has happened? This stupid toy suddenly purchased over the entire country. Was it a dog toy?
Yeah.
Maybe it was Petco and not Toys R Us.
It was a dog toy.
Yeah,
and
somewhere.
They were so few available. They gave each team one or two. First is still pretty bad at supplying game pieces, but not this bad. Mm-hmm. This year, it was the worst ever. It's every team needed 30 of these. And I remember you were calling
and they broke. They broke.
Yeah, and they broke. I remember you were calling Kentucky. It's I found 7 in Kentucky.
I actually remember calling Kentucky. I wonder if I could find that in my email.
I remember teams were trying to make their own out of polycarb and folding it around and putting cloth around it. It was a nightmare. But we did manage to get enough. We did a good job of that, I think, of procuring.
Yeah. I have an email from Nancy Abrudi that says that was trying for us. They wanted us to send them balls, and then the price that they were going to pay us for the balls. And then it said, which will basically cover our costs for having received balls from Washington, Rhode Island, and then she wrote Kentucky or Kansas. I can't remember, something with a K. So apparently we purchased balls from Kansas or Kentucky and Washington, which is really far away.
That's crazy. It's because of stuff like that. Like during kickoff, we have a student who sits in the audience and is just ready to purchase. Like I just go through with them and we purchase the game pieces immediately. One thing I actually skipped by that was different about this game that I think is worth mentioning is they changed the control system for this game. They used to have the IFI control system, but they switched to the Seaon. The first year of the Seaon was the first.
Do they still use that?
They changed it. It's the Robo Rio now, and I think they're going to change it again in a couple of years. The Robo Rio is much better.
Similar thing from National Instruments.
Yeah. But I do remember that there were issues with the wheels and the regolith producing a lot of static. Do you remember that?
Yeah.
And they were like, reporting that they were like fry their Rio and stuff.
I kind of remember people like playing around with discharge straps touching the ground and stuff like that. Yeah. I don't even know.
Teams still do that.
But yeah, I actually at home, I have, because there was like 1 year. So previously it was the radio controlled IFI one, very simple, but it worked. And then the next year there was the Rio, but they had a dedicated piece of hardware on the operator interface that was like this blue box. And I have one at my parents' house that just says "don't work" on the back. And I don't know, I took it home because I thought I might do something with it at one point. Should bring it back to you at some point for like a museum. But yeah, those
a couple of those actually still.
Do you? It's not.
They're Wi-Fi routers.
Really?
Yeah.
Well, I don't know. But basically, they moved away from that and went to laptops like almost immediately following.
Well, actually, I don't think immediately. I think they didn't make that change until like 2012.
Really?
I'm not positive.
It's hard to remember.
But there were issues for sure. But yeah, continuing with the drivetrain stuff, though the off-season drivetrain wasn't obviously going to be used, we weren't going to use that design. We did put slick wheels on it. So we could practice with it, which was incredibly valuable for me as the driver because I could really get a feel for how this was going to go. And we could play around with some ideas. I remember we played around with like trying to do some sort of traction control, which was like hit and miss.
So what I remember about that was that there was some caveat where you could have other things touching the ground if they weren't part of your like drive system. Also, just as a side note, the person, Joe, I know you know this, but for everyone else, the person sitting on that is Emma Gilsands, who started a pretty successful company that runs in New York City now that does elder care. So it's like connecting young people with old people to like help with senior citizens' needs who don't necessarily live in like old folks' homes, and then sort of a bunch of things around that. She's also someone I happen to see almost every time I go to New York, just on the street randomly. But she's doing pretty well.
I haven't seen her forever. That's great.
But sorry, what was I? Oh yeah, that is you. I was like, who is that? It's you. You're more handsome now, Joe. No, we played around with the idea of having an idler wheel essentially that sat under the under the robot, that with the idea that we could compare the rotation of the wheels to the rotation of the encoder and look for deviations to identify if we were slipping or not. So, in the scenario you slip, the encoder is not logging a lot of rotation, but the wheels are logging a lot of rotation. And in that scenario, you could sort of artificially cap, if Joe like shot forward with sticks and the wheels spun out, the encoder would say, we're actually moving at the rate we should. Let's slow the wheels back down to let us like get some traction go and then speed up slowly. And you're right, we played with traction control where we like auto limited the rate of acceleration of the wheels basically.
Yeah, but I think what we ended up doing in the end was just
driving
the input or something, just like slowing down acceleration. We just did something with that in code, and it worked pretty well. And it's interesting you mentioned that encoder thing, because I remember we took like a Vex like robotics little green Omni wheel, and we put it on the bottom. Yeah, but
and it just hung down. I remember we had problems with it like breaking off.
definitely had problems with it breaking off. I remember one time a ball went under us and caught it on it.
Yeah.
Um,
Yeah.
but we really, we just went with a simple drivetrain, just like 4 wheels. Was it 4 motors or 2 motors? Do you recall?
I think it was 2 motors.
Okay, yeah.
Because we determined that all the advantage you would get from additional motors were better acceleration under load or better pushing, at like the high ends. Oh wow, I haven't seen these pictures in a while. Where can I get these pictures later?
They're on the website. You
Okay.
just go to Team History and look at pictures from that year. But yeah, you're right. It looks like it's just 2 motors on here.
Yeah, because we just decided that you really didn't get any benefit from it without with the slippery surface, and so
I think the thing that we overlooked though was doing more wheels, like maybe multiple wheels on each axis, because that could have helped with traction and also lowering our center of gravity. Because I think I was reflecting on it the other day. I think we would tip up sometimes when we were in pushing matches, and it made it hard for us to get at the pins.
Dude, look at that ancient monitor in the background. Do you guys still have those?
No. We definitely
I'm
we definitely had a couple when I was there. This arm, it took me a long time to unload that onto somebody. This robotic arm.
I never saw it work. Oh wow. Can you zoom in again, Joe? I remember how excited I was about this like tiny part of the design. I know I can't. Yeah, where your cursor is right now.
The holes or the motor?
Milled out just the way the motor mounted inside that piece of extrusion. There was like clearance on the backside drilled out, and then the inside of the extrusion was used to replace a faceplate on the gearbox, and it just felt like it was so integrated, and it just worked really well. I don't know. I feel like everyone has this, but there are little parts, and actually on the other side you can see a little bit from the other angle. There's just parts of these designs that even to this day I remember like being very satisfied with some tiny aspect of it, and I remember loving how these motors were mounted.
Did you remove the outside plate on the gearbox, or did you just put the outside gear plate flush against the plate?
I'm trying to remember. I'm looking at these gearboxes, and these are Bane bots. I think it had its own plate as well, because if you look at the plate we can see over here on the left side, it looks like it's probably a 1/4 inch thick, and the walls of that extrusion are probably 1/8. So I think it didn't replace the face of the motor.
The interesting thing is, I think this was the first time we did something like this, and now today it's something it's pretty standard for us for motor mounting. We do it this way. The clearance hole doesn't look like a circle. It looks like it's the same shape as the gearbox. It's like a square with fillets on the outside, on the corners. But yeah, I think about it. I don't think we ever did this before. You did it this year, and I think we just kept on doing it year over year. It's a part of the design that stuck. Okay. Let me jump over to the next thing I had.
I do remember these gearboxes were kind of bad. The ones
they were
in the
bad.
Sims.
These BaneBots gearboxes.
These were BaneBots. They just they stripped. They had problems. I mean, they weren't even mounted very cleverly. Oh, Joe, I remember a thing we did here. So if you see like by Joe's cursor, the plate on the gearbox is taller and goes below the sort of channel of this drivetrain frame. And so the motors, they're sort of like this. When there was a load on the wheels, was this robot? I remember the gearbox is flexing. And so we took 2 pieces of tube and we connected the gearbox and hose clamped them together so that they provided rigidity to both gearboxes.
Yeah, I'm not sure if it was this year or not, but I do recall us taking a
I can't
like
remember.
One of those online metals cardboard tubes that our metal would come in, and we sawed it down to size and just used that like you're describing.
Cardboard?
Yep, and we just hose clamped it,
Right.
and that worked well. And I also remember these gearboxes breaking. It was the last day of build season, just while we were
last day of build season.
Like the last minute of build season.
It was like right before going in the crate, and then that morning, or the morning of the competition, me, you, and Joe Ricci went in to uncrate the robot, and we had all of the replacement parts hidden in our bag, and we fixed it before the rest of the team even came into the Javits Center.
I don't think it was me. I think it was Betsy. I don't think I fixed that.
Really?
Yeah.
Well, whatever. I remember you being there, Joe. We'll keep it that way.
I was not that mechanically savvy back then, for sure. I didn't know what was going on. You're just giving me stuff to do. Okay, so let's go back to kickoff, because I remember when, like, right after the kickoff, we went back to Whole Foods, and it was me, you, and a couple other people, and then you were in a corner just drawing on a pad, and you know what I'm talking about right now, right?
Yeah. I'm gonna get. I meant to grab this book earlier, but I'm gonna grab the book because I had this book. I brought it.
I have a picture of the robot. Oh, Seth went away. But Seth's basically just had a realization that he had the perfect robot for this game. And no one had any idea what he was talking about.
This exact copy, because I still have it. I guess I don't know why I'm doing this. You have the picture up. But yeah. This was in this book. And I, to this day, don't know why this is what sort of like did it for me. But I was just looking at this robot because I thought it was just slick design, right? There wasn't a ton going on. It worked really well. And the sort of thing that clicked was like rearranging the parts of this so that the big hopper was on the top, at the top of, like, you know, their conveyor belt where all the balls would sit. And then actually we ended up having, like, I know I'm using my mouse so you can't see it, but the what do you call it? The ball acquirer. We ended up having one on the bottom. Yeah, the intake. We basically duplicated this as an outtake, as an outlet as well. Same idea, PVC polycord. And so we had this huge, you know, the conveyor belt, I mean, probably to the robot, was the full width of the robot. That was one of the things I took away from this design, was that it was just so easy to get a ball right. We wanted to make this as simple as possible. So anywhere on the front of the robot that it hit. And then I saw their hopper and I was just like, put the hopper at the top. And, you know, I think the beauty of this was that there weren't a lot of places it could fail, right? There wasn't a ton of moving parts. It was all just motors turning on and off. They didn't really need to be speed controlled. The worst part of this robot actually was this, which I totally forgot about, was this thing at the very front, the supercell, like, toggler.
Yeah.
That
and it still wasn't that bad.
Yeah.
Yeah. So, you know, when you first drew that, I had no idea what you were talking about. And I don't think you just basically drew a 7. Like you did like a side view of this robot and you drew a 7, but I began to kind of understand what you were talking about. And I just remember the next day coming in and you showing the design to Joe and he's going, this is a 7. But, you know, as I kind of started conceptualizing your idea, I thought, okay, what would be valuable for me to prototype? Because we started prototyping all these different ideas. I remember Joe was working with some students on a conveyor with hooks because these balls had holes in them. And I think it was the most dangerous prototype I've ever seen. Because he just basically had this conveyor of sharp hooks spinning on a drill. So I took a cardboard box and I put it on top of Jack, because Jack is basically the bottom part of this robot. It's an intake and it's top part. And I basically put a cardboard box that was the right size about. And we kind of saw conceptually what this robot could look like. And we put the balls in and we could see basically how many balls we could fit. We saw we could hold about 25. This kind of worked strategically. And then I remember you built a shooter prototype, right? Like you, I think you hooked a sim motor up to it.
Yeah, I almost feel like the original, it's been a long time. I kind of feel like the original cardboard box just had a flap at the front and you're just like, look, you open the flap, the balls come out. So I can't actually remember how we ended up with the shooter. I feel like this was I remember going into this year, you and I just going on and on about how great rollers were. Like, rollers all day, rollers are great. I still to this day think that's the case. And you know, that's probably how we ended up with the roller at the top. But the roller at the top worked well.
Yeah, although it had room for improvement, and you improved it throughout the season, but it did work.
Yeah, I do remember that.
But you know, the crazy thing is, this was basically the ideal design for this game in terms of concept.
Who won like nationals this year? We weren't there, so I don't really remember.
Those 111 and 67 were the Alliance captains. Sorry, there were the two.
And 111 had an overly complicated turreting shooter, right?
No, that was 11-14.
You sure?
11-14 had a turreting shooter.
Maybe
111 looked
maybe
a
that was
lot
111
like our
in
robot.
2006.
111 looked a lot like our robot, except they did have a swerve, and their hopper actually raised up so they could hold even more balls. So it would like start low and move up. But this was Howard's saying 111 also had a raising lift to push the balls up to the top. Yeah. So, but this was like a very common design that the top team, all the best robots had, like some formation of this. And it worked really well. And I remember you and I were like very fixated on you go up close, you score. You pin the trailer and you score. Just like keep it simple. That's our secret sauce. That's what we do. And then a lot of the mentors wanting us to score from multiple places.
Yeah. The pinning was really key. Because a lot of teams tried to be fancy and use the computer vision target and score from all over. But if you could get close, I mean, if you pinned one of these, you just emptied the whole hopper in the back of the robot.
Yeah. You just do it fast.
Yeah. Do you remember our first match?
Yeah, go ahead.
Because I do. I remember, I'm trying to remember the team name. I think it was 1100. It was one of these, like, at the time, newer teams that was pretty solid. And it was a practice match. And so it's not going to be on here.
Oh, okay. It was probably 2753.
No. I remember them. They only existed for like one season, but whatever. It was a different team. It was like, I think it was in the 1100s. And they were just a good team. And we were against them in a practice match. And first time out, right? We'd never actually driven against other robots. And that was a weird thing about this game, was that you couldn't practice by yourself, really, because you were trying to score on other robots, and we just dominated. And I remember by the end, like, that sort of butterfly feeling, and I remember being like, we're going to be really good.
I actually do remember that match because it was my first match ever driving on a field, and my legs were jelly.
Yeah, me too.
Yeah, and then I remember one of us turned to the other one and went, my legs were just jelly during that match. And then the other one went, me too.
Yeah.
So, going back to the build season, when we came to the drive base, I just kind of want to go through a couple of things. We talked about the motors and gearboxes. We talked about the number of wheels. I remember like week 1, week 2, we were talking about drivetrain configurations. I think one of the best decisions we made was going wide. That was particularly good.
Yeah.
Well, that year it wasn't like frame perimeter. Now it's frame perimeter. It's like whatever your total frame perimeter is, so you can do a bunch of configurations. But that year it was like.
So you could go super long and skinny?
You can go super long and skinny. You can go octagonal.
That's cool. Yeah, this year it was like max dimensions. It was like, yeah.
It was like your 36 by 28, whatever orientation that is. Your 36 by 28. So we went wide. And the reason we did that was twofold, as I recall, because I remember the conversation around it. It was maximum intake size, because you couldn't extend outside your frame that year at all. So maximum intake size and easier turning, because we were wide and we were going 4 wheels. But there was an unintended really great thing about going wide, which is that the trailer fit in kind of perfectly in your intake. That you could pin.
I don't think we intended that when we did it, but it was like
100%
it was so valuable.
Did not intend it. But
yeah,
the trailer
it
would
was
just
like
fit
you
in
were
here perfectly.
If you drove up and you hit a trailer, it was like a round thing. It guided itself into your intake, and you were just perfectly positioned to fire the orbit balls in.
Yeah, I'll play a match in the
Joe.
background as we continue talking.
I haven't watched these matches in a long time.
Of course, the
video is
doesn't work.
Oh God!
But
why are you doing this to me?
Sorry. Continuing with the build season. This is a great.
What a match where we work, Joe. Look at that.
No, we worked in this match. We definitely worked later in this match. But going back to the build season, we spent a lot of time debating the lip. I remember Cologne always wanted to do like a little lip so we can score from a foot away, but it made us so much worse scoring from up close.
Mm-hmm.
I just remember that was like
Yeah.
such a huge waste of time, that whole argument.
There was another thing there though it was not just the lip, but like there's a roller and then there's a ramp, right? And if you have a straight, a line next to a circle, your distance from the circle varies as you rotate around the circle. And so what we eventually changed to didn't have a lip, but it was a radius. So the distance from the, oh, you can see my dad in there, Joe. You see that?
Yeah.
It's in the bottom right.
But yeah, actually, so that was one of the things we missed about the lip, was that lip design. The plate that had the lip on it was that it had that really nice outtake like you're describing.
Yeah.
The plate
was that better in the end? I can't remember if
you could unload.
it was much better.
I mean, it wasn't.
Yeah.
It was probably like it took us a good second off of the unloading time.
Yeah, because I remember previously the balls kind of popcorned around because it very quickly went from the roller was too far from the flat to grab the ball to it was so close that we actually broke balls sometimes, which was not like technically allowed.
But the one nice thing about scoring slowly was that, like, if you were off, you wouldn't just miss a whole like payload.
Yeah.
You would you have time to adjust. So that was the one downside. We actually only incorporated that change in the off season, so we never really tried it in the regular season. Okay.
Yeah.
But that was one thing we definitely missed about that when we were having that debate. Continuing with the build season, I remember when you put me in charge of building the conveyor, and I had no idea what I was doing. And I like to think
Sounds
that
about right.
Every student has that kind of that mentor that was like their point person. And for me, it was definitely Ron. My whole career. Earlier in the season, he literally saved my life when I got a piece of tubing caught in the drill press and it started spinning, and I just dropped to the floor and went, "Help!"
I don't remember that.
But yeah, I was just stuck on the conveyor. Every other part of the robot was done, and I was working on the conveyor, and I just couldn't figure out how to get the sprocket attached to it. And I remember we were having a dinner meeting, and people were just like, "What's going on? What's holding it up?" And I was like, "I don't know what to do."
Oh yeah, I remember this.
And Ron was like, "Do you need help? Ask for help. Do you need help?" And I'm like, "I need help. I do need help. You're right. I'm sorry I haven't asked. I need help." And by the end of that meeting, we had gotten the sprockets onto the conveyor rollers, because I'd done all the rollers and the tread. I was just stuck on figuring out how to get these sprockets on. And I would say like the next day the conveyor was done. But
what did we end up doing?
Well, so we did. There was like it was the sprocket. I don't think it had a hole in it already, so we drilled a hole in the sprocket and then tapped it, and we drilled a hole in the roller and put a screw.
Because it's that PVC roller.
Right. And then I remember we had a lot of trouble getting the conveyor on because the polycord was so strong.
Yeah, it was really strong.
And it took like 5 of us to pull it up and like smash the shaft through.
Do you remember how we made that polycord?
Fire.
I mean, you literally, fire. You bought it in these big spools. So you cut it to length, and then you like with the lighter melted either side and stuck them together. We had polycord on a robot this past year. Did it the same way. We actually a few years ago, someone made like a mold. They took 2 pieces of aluminum and they drilled a hole, 1/4-inch hole through it. Like basically, they took a solid block of aluminum, drilled a 1/4-inch hole, and then they cut it in half, and then put like a strap between them so you can use it as a mold when you're putting the polycord together. Yeah, I think someone made that in like 2011 or 2012. It works really well. Okay, so I was just curious because I've always called this polycord. I didn't know what it was. It's made of high quality TPU.
Yeah, polyurethane belting.
And it's used for conveyor belts. We were using it for its intended purpose. That stuff is a great material.
Printer.
We'll get to. I'm sure we'll get to this in like 3 hours or something. But the printer that I'm working on right now, one of the materials it can print is a TPU, which which is cool for because of some interesting properties of that material.
What do I want to talk about next? Oh, so I think one of the main things that made us so successful this year was that we got the robot finished like week 4. So basically, like once I was done with the conveyor, everyone was done with all their mechanisms. You had catted the entire robot between week 2 and 3, like over that weekend, like you said. So we just kind of hit the ground running, and 2 weeks is all we needed. It was a simple robot, and
it was a simple robot. Yeah.
The I don't think like our control system was like quite there yet because it was a new one. We hadn't really used it before. But I remember Ariel hooking up a Vex controller to the robot. And the first time we ran it was on like one of those old big Vex controllers.
I do remember that.
Together. And the electronics on this robot, you can kind of see it in here, is on this vertical board, and it's
the vertical board. I remember that.
Yeah, took up a lot of space and raised our center of gravity, but it was beautiful. It's just so well organized. We never had an electrical failure the entire season, which was
one of sorry, go ahead.
It was just like a big part of our success was just like we never disconnected. The year before we had a lot of those issues.
One of the I never would have made this connection, but I'm looking at it right now with the electronics in the back, and it's very similar to the 3D printer that I'm working on right now. It's like the size of a mini fridge, and it's got the bottom lower half of the back is all electronics panel with electrical with the circuit boards and all the wires routed out around it. It's very similar. I mean, it's not like a particularly innovative concept or anything, but it is also very clean.
I mean, I think clean electronics are a big differentiator in FRC because like sooner or later, if you don't have clean electronics, something will go wrong and you won't be able to debug it quickly because your electronics aren't clean. Okay, anything else from build season? Oh, the eyes and teeth. We got to talk about those. Absolutely gorgeous. I believe Bess worked on those.
I think Bess made those, yeah.
Yeah, I think she worked with Catherine Kanicki.
Yeah. That was like, I mean, talk about a thing that, it had no function, but it just, everybody knew what the robot looked like. It gave it so much character, and yeah, I don't know, man. I love those eyes and teeth. They were so well done. Fantastic.
I mean, I'm a big hater on decoration because of the time you put into it.
Are you? I didn't know that.
Yeah. Well, I'm just like, I'm all about time. I'm very fascist in that way. But these, like, Bess just kind of did her on the side and then just put it on. So it was like, it didn't slow anyone down that she did this, and it just looked so good. And you're right, it gave us like a personality. There was an intimidation.
Oh, look, Joe, there's another motor mounted inside that electrical extrusion up top for the ball spitter. All of the motors but the drivetrain. Yeah.
And we actually 2 years ago we did a climber, and we mounted a motor very similar to this into our chassis. But it wasn't for the drivetrain, it was for the climber. It was just placed there.
I don't know how much you want to talk about things that aren't robotics eventually, but
that's okay. Go ahead.
We use extrusion. We use custom extrusion actually a ton at Formlabs. You wouldn't realize it, but aluminum kind of behaves like clay when you apply enough pressure, and extrusion tooling is actually really easy. It's not that expensive. It's easy and quick to make. The design constraints are pretty forgiving. So we sort of have two ways of making like complex 3D mechanical geometry. Sheet metal is one that we rely on heavily. I could talk to you endlessly about how much I love sheet metal design, but we've also done a few things, and I can share my screen later and show you some proprietary. I guess they're putting this on YouTube, but I can't really do this. But I
can pause it at the end. You can show me, and we'll just
maybe we'll do it at the end.
Or you don't have to if it's proprietary.
Yeah, it's whatever. But we make a bunch of custom extrusions and fit them together to create similar like 3D geometries. It's a pretty cool manufacturing process that I didn't really appreciate, both the like flexibility of and the relatively reasonable cost until now. But all this to be said, if anyone on StuyPulse wants to design a custom extrusion, it's not going to be something you can do within the time frame of a build season. Basically anything that's tooled isn't. But if you have a cool 3D geometry that you want long aluminum tubes made out of, it's pretty accessible, and I think the tooling is within the budget of the team, and it's a cool technology. You probably see them.
You could definitely customize something that would, fit towards our design.
Yeah.
All right. Okay. Let me see if there's anything else I wanted to talk about from build. Oh, the LED goggles. So
you got to remind me, because I saw this and you wrote didn't work, and I was like, they didn't work so much that I don't even really remember them.
So I remember our software team, there was like a couple students who worked on a pair of goggles for me that would go on the operator station, the OI operator interface, with 3 LEDs. One was green, one was yellow, one was red, and it was connected.
Yeah.
And it would use the camera to tell me like if we were aligned, right? The only issue with that is that I also have eyesight, and I can see if we're aligned. And I just remember this huge argument over it, and it was like people wanted to keep doing it because like someone had put into the work for it. I was like, we have bigger fish to fry. We have other things to do. This isn't a good use of our time. And that kind of goes back to your earlier point when you're talking about Sakif's drivetrain add-on. It's like this trade-off. I think that was the first time I had experienced something where I was in a position where I was like, had a say in should we continue with something or not. And it was definitely tough for me to be like, I don't think we should do this. We have better things to do, and this isn't adding anything valuable, even though this, students worked, plenty hard on it, and it actually kind of worked.
This is the sunk cost fallacy, right? The idea that, if you spend a bunch of time or money on something and then it's not useful or you shouldn't use it, like people kind of, their gut feeling is to proceed with it because they've sunk all of this cost into it, but actually it just ends up being more expensive and less useful.
Yeah. And my view on it is for FRC, it's not a science fair. Like, it's not about creating a thing and being like, oh, I made a thing. It's, you're part of a team, and sometimes that comes with like some sacrifices, which can be really tough. But, that's why we have off season. That's why we have off season projects where kids can explore these things, where they don't necessarily get that chance in build season. But it can be really tough because FIRST Robotics is very different from any other kind of science project. With any other science project, you're going to see it through just to have that experience of making it. But when you're part of a team, part of a competition, you're not always going to do that because sometimes it doesn't make sense. And I just remember like really wrestling with that whole thing and like how to handle it well. And I definitely didn't handle it well. And I definitely I think the student working on it was like upset a little bit, and then we kind of got over it.
I mean, even I can't remember a thing that I was so emotionally invested in as FIRST Robotics. So all of those things are magnified because you care so much.
Mm-hmm. Absolutely. All right. So, is there anything else you want to mention from the build season before we start talking about competition?
This is a random question, but are we doing 2010 as well? You didn't write any questions down about that, but
no, not 2010. We would do that on a different day.
All right. Is you going to pick me to do that one as well, or somebody else?
I was going to ask you, but I don't know if you want to do it. I might want to shuffle it around so you don't have to do consecutive ones, but I was hoping to get you.
I'd be happy to be on your podcast again, Joe. Okay. This is way more fun.
I was hoping to get you and Betsy for 2010 because we made such strides in marketing in 2010 with her as president of marketing, but also she was involved in engineering. So I thought it'd be really good.
I ended up texting Betsy the other day. Accidentally, I meant to text my mother, and somehow iMessage added Betsy to my text. So I started texting, I thought just my mom, but it was a group text with my mom, Betsy. So I caught up with her. She's doing well.
Nice. And I saw her last summer. She's at SpaceX, right?
She is at SpaceX. Yeah, at Andrew's wedding.
Yeah. So, okay, let's talk about the New York City Regional. We came in and, we were just kind of like, especially in practice, I feel like we were in the second or third practice match. We had to do those drivetrain fixes, but they didn't take very long. and we just kind of hit the field.
Yeah.
We got a ton of practice in. We were just doing really well. And I remember during practice day, we had this big debate is if we wanted to put time into practicing with the empty cell.
Yeah.
So I'm just going to explain kind of the mechanics behind that. So I'll go back a step. You see this human player who's sitting in this video, put a ball through this hole onto the field. So the empty cells and the moon rocks were both worth 2 points. And you needed to take the empty cell, deliver it to your other human player, and they could exchange it for the super cell, which is the green one, which was worth 15 points. So we have this like special mechanism called the Ricci apparatus.
I forgot that it was called that. I feel bad now that I said it didn't work very well. Don't tell me.
Well, the thing is, it was called the Ricci apparatus, but I don't know how much he really had to do with it because I believe Jake Potter and his dad built it. It worked decently well. It was like, I'll go back so I can show the picture of it.
I'm gonna grab a slice of pizza, but you got me on audio.
Sure, I'll play. So it's this thing that says Michael 1 on it. It's a flap, and there's these two pieces of conduit. So the ball would go through the slot onto the conduit, and then the flipper would flip it out to the human player. And it worked decently well. You could go to the human player, and you could get the ball, but you have to be lined up pretty well. And really, for something like this, we really should have used, I think, rollers to do it, but
yeah,
pretty well. And I don't think we really gave it much of a shot. But I remember you, specifically you and Joe, arguing about whether we should use it or not.
Yeah, I remember not liking it. It was just precarious. It all relied on gravity. The ball just sat there.
It wasn't good enough.
To the credit of the people that worked on this, we had very tight constraints. And you can see it in this design. Well, if you go back, right,
yeah.
we were very tight on weight. So this thing needed to weigh as little as possible and be as easy to interface into the software and the electronics. So it's just a tiny little servo and these 3 thin aluminum tubes. So the whole thing weighed nothing. But if the ball was sitting in there and you got jostled, it came right out.
Yeah, but I do remember that if there were 2 balls in there, they would be stuck.
Yes, I do remember that.
Because it couldn't handle the weight of 2. I mean, it wasn't part of the original design, so it was very difficult for the people who made it. And like you said, to their credit, it's actually kind of impressive that they made something that worked with those restrictions. But I think if I were designing,
Michael 1 on it.
Yeah, and also it looks great.
And the NASA letters.
Yeah, really cool. The styling of this robot's insanely cool. But I think that if we were designing this from scratch, we would have some sort of active rolling mechanism, like 2 rollers. So you drive up and you grab the ball, and that's it. But I also do think that it worked well enough that we should have given, like looking back on it, we should have given it more of a try, especially in the practice matches. But I also think that we were kind of like in this range we'd never been before, where we looked at the competition and we're saying, we're one of the best teams here. We should win this. Let's not rock the boat too much. We just play our game and we'll be okay. But I think if it were today, we would push to give it a try and make it work, because it did access a level of points that it was hard to get from the other game pieces.
Okay. I remember. I mean, I couldn't tell you the match, but I remember us using this effectively at least a couple times.
No, so we actually did score.
We didn't.
We never used it. There was one time we picked up an empty cell, so we just decided to drop it off, and then we got a super cell and scored it.
I see.
But I don't think there was a time that we ever used it. I'm actually positive there wasn't. Okay, so we go through quals.
I'll believe you. I'm not going to go watch all the matches.
No, that's okay. You should, though. We go through quals, and we're playing really well, and the 2 best teams, in my mind, are clearly us and 2753. Who was actually a rookie that year, and this was week 2. They had won the Trenton Regional in week 1. But
they never played. That was their only year in competition, right?
No, they competed in 2010 as well.
Really?
Yeah.
Oh,
so
they were
originally
they were
one of the best FTC teams, or it might have been Vex back then, in the world, and they changed over to FRC. And they had this one student. I remember Tyler, who was really great, and he became an FRC mentor for Team 2016 for a few years when they went to Einstein, Tyler Moser.
Friends with him on Facebook.
Yeah, he was a really smart guy. I don't think he's really in first anymore, but he was a really smart guy. And he
works
really,
at Honda.
Yeah.
That's cool.
So we go through quals, and we don't seed super high because New York City had like 7 matches back then. You had 7 qualification matches, so if you lose one, you're not gonna seed first. We lost one, and then we got a tie on another match, I recall, because one of our alliance partners, the driver was wearing the coach pin, and that was a 10-point penalty, which is like the stupidest.
Joe.
What, you remember that?
I had forgotten about that. Oh, man, that was so terrible.
Yeah. And it was just like, it was so heartbreaking because once that happened, we knew we wouldn't get the number 1 seed. And 2753 had already lost. So we knew, okay, well, now we got to figure out a new plan.
Because I remember we both wanted to be on the same alliance, and that happened, and it was suddenly like we had been with this team, the whole regional, we knew we wanted to be together, we knew we were going to win, and then that happened, and I remember watching that match being upset because screw the plans. All right, I'm actually getting pizza this time, but
okay.
Right back. Keep going.
I'll describe it. So nowadays, if your coach has to be wearing the coach button, your driver has to be wearing the driver button, which they're different buttons. It used to be for years that it would just be a foul if you didn't correct that, which was, in my opinion, the dumbest thing ever because it wasn't about the coach driving. They don't want the coach driving, right? Which makes sense. Like, the coach shouldn't be driving. But that's not what was happening. The driver was just wearing the wrong button. So teams were just getting fouls left and right. It became a thing where before every match I was checking the buttons of our partners. It was insane. So they changed the rule a few years back where it's like, remedy it. The referee will tell you if it's wrong. And, if it's before the match, we won't start the match till it's remedied. So it's just like, that makes sense. Why isn't that always the rule? If the actual coach, like the adult, is driving the robot, then yeah, that's a problem. Give him a red card. So they fixed that eventually. But I just remember
that's good because nobody was doing that. Nobody was actually like trying to sneak their coach in to drive a little bit better. I mean,
and if they were doing that, they would wear the buttons accordingly. The buttons had nothing to do with it.
Yeah.
Like, oh, I'm an adult. I'm 28. I'm gonna drive this robot, but I'm gonna wear the wrong.
So it's not
button.
like the adults would be better at it. You imagine
much worse.
Just one match being like, we're gonna put an adult in who's never done this before.
So bad. I mean, the real part of the rule that's important is like, let's say I'm drive coach and I want the drivers to make a slight correction. I shouldn't be reaching out and touching the controls to make that happen, right? And that's something that could happen. I instead, if I want to,
I could have seen Joe Ricci doing that.
Yeah, I definitely could. I do instead. Like, if I need them to make a correction, I'll smack their backs and go, do this. I don't even realize I do it. Bryant, who was the driver this year, was telling me that I do this. And then I look back, I'm like, oh my God, I do that nonstop. But I don't touch the controls. I think there might have been one time where I momentarily touched the laptop because the screensaver was turning on.
Have you done 2007 yet with the controls and the control failure and finals?
Yeah, I did that. I definitely.
Who'd you have on for that?
I did 2006, 2007, 2008.
Who did 2007?
Sammy.
That's awesome.
Yeah. Okay, so we were clearly one of the best teams between us and 2753, but we weren't going to seed first. 375 seeded first, and they picked 2753.
Yeah.
Although I would argue we were better than them. They were definitely really good, though. I might be.
I don't know. My memory of it, and I'm obviously biased as well, was that they were a little bit better than us. But I can't really remember why.
They were very good. I'm not going to argue that. They went to Einstein that year. They were the first rookie ever to go to Einstein.
Yeah.
So then I think the number 2 seed didn't pick us for whatever reason. And then
It's a bad strategy.
And then the 3 seed selected us, and they weren't strong, and we said no. And I remember I was out there for line selection, and I went, we regret.
Oh, they got so mad at us.
Yeah, they got very upset at us for declining.
Parents screamed at us.
It's usually the parents who get the most upset. It's usually the adults who lose their minds.
Yeah, that was sad. I didn't like that.
That was about, like, in my time as a student, that was Cologne's one endearing moment for me, was that he really had my back in that. He was just like, get the hell out of here to that parent. It's like, you're no, absolutely not. He just like had our backs. But yeah, we said no. We declined the 3 seed. We were the captains of the 6 alliance. We picked 395, who was really good, and I couldn't believe they were available. We actually picked a strong alliance, and then I forget the team number of the other team we picked. You can actually see right here. 3111, who was a rookie but really strong. They were just a good defender, and they started with however many balls you started with. I think it was 9, and they just dumped those, and then they would play defense. And we felt good, even though we weren't the top seed. And then we cruised through quarterfinals, just demolishing the 3 seed who picked us, which kind of felt good because that parent had yelled at us.
Yeah,
and then we go into semis, and we just got abused by 743.
I still remember that number, 743. This is gonna suck to watch.
Yeah, this is hard to watch, but they actually, when we won the 2018 New York City Regional, we picked them. Oh, I haven't mentioned the autonomous. You can see it here. We would line up to get loaded up from the human player. So Johnny would load us up in Auton. It was really good.
I like this just as a side note because that was a risk, right? Because if you didn't hit the shot, you could score on yourself.
Right. But the human player loading in auto, we definitely fixated on that early. And just being able to human load really easily, we wanted to make that the hopper really open. I think the team that I looked at a lot was 25 from 2006, who just would only human load. And I had considered the option of only being able to human load in this game, but you had such a great idea that I'm like, why wouldn't we do this in taking 2?
That would have killed us, I think.
That would have killed us. But, loading up in Auton was really great because then we could score really fast while, teams missed and balls ended up on the ground and human players missed, balls ended up on the ground. So our first load was always, go to the human player. We have the 9 balls or wherever it was, in our conveyor. We load up in the hopper, and then we go score that first load. And by the time we're done with that, the field is full of balls, and then the rest of the times it's just pick up till you're full, score, pick up till you're full, score, and just cycle till the match is over. There really wasn't an end game to this game.
Yeah, there was no end game. There was no end game. It was just the supercells.
Yeah, the supercells you can only do in the last 15 seconds. That was the only real end game part.
You can see my dad in all of these videos. It's funny.
Oh yeah, so Howard just posted this in the chat that if you won by 2 or 3 times the amount of your opponent in a match, the next match you would lose supercells. You wouldn't have supercells available to you because they didn't want.
Whoa! Say that again.
If you won a match by double your opponent's score, you would lose a supercell. If you won by 3 times your opponent's score, you would lose 2 supercells. Something along those lines, to prevent teams from really. So like teams would score on themselves at the end of the matches sometimes because of this.
Oh, I forgot about that. Yeah.
And there was also like ranking system. Like if you part of your ranking score was your opponent's score. So you that's something.
Yeah, that was new that year.
It actually I think was around in 2008 as well. We didn't put emphasis on that, which was a mistake. Our ranking scores were always lower because that was a tiebreaker. Whatever your opponent's scores were pre-penalty was your tiebreaker. But we should have done that more.
Sorry, Howard. I'm just seeing all the messages in this chat. I hadn't opened it up before, so I missed all these other ones. But I'll keep it on my other monitor now.
Yeah. So 743 abused us in the first match. This is the second match, and this just alliance just was fixated on getting away from us the whole match, and 743 trying to target us.
Yeah.
And yeah,
they played well. I can't remember. I feel like I came away from this feeling like they kind of abused the rules, but I wasn't sure. I can't remember.
No, they played it. They played it totally clean. They were just very well driven.
It was just a box bottom. I mean, they didn't do anything, right? 743. Right. except ruin our chances of winning.
And it was just like everyone in this match was like just out of reach. Everyone would just slip away, and then we get pinned. Like they would wait. It was like they would bait us, and we'd get in against the wall, and then they would stick us. It's like they just stuck it. Like the rest of this match, we couldn't move.
Yeah, they drove well.
Yeah, really well. They had a lower center of gravity. I think that was a big part of it. And just the thing I really remember vividly was after the first match when we got stuck, is we came back and it was just like a frenzy. And I remember Joe saying that 395 was going to play counter defense instead of scoring.
Yeah.
Which was a big mistake because really with 743 pins us, then 395 should be scoring on them like crazy because their trailer's just sitting there. And we couldn't really take advantage of that. But I definitely I remember just between New York and Hartford, just watching these match after match. It was almost like sadistic. Just like
it's just really painful.
It was just like forcing myself to watch it to just get better. So
I know when you said we were going to watch these, I didn't feel good about that.
Yeah, these were definitely tough. These were tough.
It only gets worse.
It gets much worse
this season.
Yeah, it gets much worse. But we come out of New York City. We didn't win, but we felt good that we built a great robot. And I remember coming into Connecticut. There used to be this thing that doesn't really exist anymore called Looking Forward. Do you remember Looking Forward, Seth?
Yeah, who was it? It was the guy from 1114, right?
No, I don't really know who it was. It was just an anonymous.
Oh no. Looking Forward on Chief Delphi was anonymous. I don't know. I remember speculating on who it was. I thought you were talking about the podcast. It was a podcast before Nationals, or not a podcast, but something where they said the best team to not make it to Nationals was us. But yes, right. Looking Forward. Damn, I remember that.
Do you want to talk about what it was?
Yeah, it was like a prediction post on Chief Delphi that was widely read. So somebody put a lot of time into it and watched tons of matches and predicted what was going to happen at upcoming regionals. I can't remember. I mean, we could maybe pull up the post, but I can't remember what they. I mean, presumably we did well in their analysis for Hartford.
Yeah. So I remember going into Hartford, and they were basically saying us in 121 were the favorites. Going into New York, they said us in 2753 were the favorites. Going into Hartford, they said us in 121 were the favorites. And going into New York's a weaker regional. We were said to be one of the favorites. I was like, this is great. But Connecticut, going into that regional and being called, I remember reading it on the Wednesday night before competition. Just being like, whoa, I cannot believe we're one of the favorites here. This is incredible. Because we've attended the Hartford regional like 2 or 3 times in our team's history. And we never even made a LIMS.
Can we find this post?
I tried looking for it. I couldn't find it. I can do a search.
Come on, we have a little bit of time. I would love to read that. I remember caring so much about what those said.
But Looking Forward came back, and there's also like a couple of other accounts like it. Like there's The Martian, who is Howard. It's like one for our area, and it's Howard, and everyone says it's Howard, and then Howard says it's not Howard, but I'm convinced it's Howard.
I don't think it's Howard.
But everyone says it's Howard. New York State of Mind. It's not The Martian. What's The Martian then, Howard? I don't know.
New York State of Mind is a good name. Man, it's been a while since I've been on Chief Delphi. It looks very different.
Yeah, they updated it.
I don't know. We don't have to look too far.
Yeah, I'll try to pull it up at the end.
Okay.
But I just remember being like, I cannot believe Hartford was one of the best regionals in the country.
It was really good.
It was the top of the top teams went to Hartford. Howard is New York State of Mind, which is the equivalent. I also think he's Martian. I don't know. But just there were so many great teams that went there. 177, 175, 121, 20, all these teams that year after year would go there and just be like big players on the national stage. And then all of a sudden we were viewed as like one of those teams, and it was very exciting. And I remember going in super hungry because this could be the end of the season.
Yeah. Because we didn't expect to win the other things. What were they? Engineering innovation or
engineering inspiration, and then we did chairman's in New York because you were only allowed to submit one regional back then. Now you submitted all your regionals.
Yeah.
And we didn't win it in New York.
Joe, when are we going to win national chairmans?
It's championship chairmans, world championship chairmans. I don't know.
All right, whatever.
I don't know.
I'm kidding.
So in terms of robot changes, the robot itself, it had 0 failures through the New York City Regional. So we didn't really make many changes. I remember you coming in and swapping out the gearbox on the shooter because originally it was drive.
Yeah, we slowed it down a little bit. The gearbox, I'm trying to remember. I remember it being a pretty small, like low, it was a planetary gearbox. Wasn't a really high reduction. And I thought it was kind of slick. It was like, it was like the same diameter as the motor. So it had the same bolt pattern and everything and the same output shaft. So you really just took the motor off, you put the new one on, and that was it. But we dropped the speed because we had this problem, right, where we'd turn the motor on and sometimes the balls would just like bounce around but not really come out. And it wasn't a big problem, but we changed it to be a curved ramp and we slowed the speed down. And
but we didn't actually change it to be a curved ramp till after Hartford.
Was that off season?
Yeah, but you didn't change the motor. You took it was like an Andy Mark planetary that was the same shape as the sim motor. It was a really smart idea. Like I just remember like, what are we doing? And then it was on there. I'm like, whoa, that was cool. That was easy.
Is this robot still assembled somewhere?
Yep, it's in the lab.
Cool.
Yeah, we should get it running again. But I think it's fully functional. It just needs code.
And probably orbit balls.
I have them. I use them for my class game.
Really? That's awesome.
But other than that, we didn't really make any changes, and we came into Connecticut and we were just like dominating every match. And like we came out of day 2. We came out of day 1 undefeated. And I put on this match. I wonder if is this the best quality for this? We won this match at the end of day 1, and it was against 743, who happened to be at Connecticut also.
Yeah.
But we like barely won it. And then there was like a replay for some reason. And I think this one's the replay at the start of day 2.
Yeah, why did we have a replay of that?
There was like some problem.
It was like a connection issue.
Yeah,
I feel like it was a connection issue.
With the field
and then it was really annoying because they replayed this one and then they didn't replay other connection issue matches we had.
Right. So we played this match. It's like the first match of the morning. I remember being super nervous for this one. And the 743 just comes out and just starts hounding us right away. We're getting stuck. I think this isn't the replay. I think this is the original match.
Mm-hmm.
I'll be able to tell you in a sec. Because in the replay, our back electronics plate came off.
Oh, I remember that.
But they would just get
it wasn't.
Into this
it was
corner.
The thing covering the plate. No, it wasn't the electronics.
Right.
Oh, nice. Gene found the looking forward prediction.
But this struggle against 743, you can see you yelling at me to get scoring.
Me yelling at you or Joe?
You. They just got us in that same spot.
All right, I found. Thanks.
We somehow got out. And we're like barely able to score a few towards the end. Like the match is already like taken away. There's like a robot sitting dead. This was the reason it was replayed because this robot died. And then of course, like as we're scoring, it starts jamming. And we finally we unload.
Oh, I remember seeing that ball spinning in the back. Oh man. Yeah.
You can see them kind of spinning in place. With the rounded plate, that wouldn't happen as much. So this was the original match. I don't know if we have the replayed match, but this was we won by just a couple of points originally, and then this match is the one that got replayed. So we go back to stick to day one, because this is day one. We come back, we're undefeated. We had a great first day. We're high up in the rankings, and then just in the hotel that night, everything goes to hell.
Yeah, as another thing I didn't remember until you mentioned this in your email. It was something so stupid. It was like Jordan. I can't remember who was in whose room, but somebody was in somebody's room after curfew, and they weren't even up to anything nefarious. They just they wanted to hang out, and during room checks they weren't in their room, and instead of just being yeah, we screwed up, sorry, we'll go back to our room, they hid. And Cologne was freaked out because students were missing. That's not a good thing, obviously. And finally he found them, and they were hiding in the bathtub of, it was Ariel and Jordan. I can't remember who was involved. Jordan, Ariel.
Ariel was not involved. I mean, Ariel and Carilla were only involved in that they were in the room. They were in their room, and they didn't really say anything, but they weren't doing anything wrong. They were just there.
Yeah. And Cologne couldn't kick all the programmers off.
Well, so it was Jesse was in there and Jordan was out of his room.
Forgot about Jesse. Yeah.
And then basically I wake up in the morning and the entire programming team is basically kicked off the team. And those who aren't are just they're relegated to the stands to sit next to Cologne for the entire regional, for the rest of the regional.
It wasn't a good regional to have our programming team diminished either, for what we'll get to eventually.
No. So we come in the morning and there's that. And also I remember the members of the team had taken the Wi-Fi router off of the OI and were using it to create a Halo LAN party.
I feel I might have been involved with that now that you mentioned that.
I remember being just furious about the whole thing, because it's we worked so hard, and it's all culminating to this one day, and this is all the stuff we decided to do. But we go and we're undefeated, and I'm super nervous for this match, and we put all this stuff aside. I remember the thing that really relaxed me before the match was they were showing some video. They always do some first video, your first whatever, they do some whatever season video, and there was a kid on the video who looked like Manav.
I remember
Manav, but Joe Ricci just goes, "It's Manav," and it's we just laughed about it for a little bit, and it was stupid and silly, but it just kind of got my mind off everything and focused on this match. And it was because it was a replay, it was one of the first matches of the day, so we were in the queue in the morning, which I always hate. I always hate doing that. All right, so we come out to this match. I don't believe we move in autonomous. Okay, let me unmute.
Member who is 2, 1, 3, 2, 1. Match number 22. This is a replay of 22 from yesterday, and it features.
There we are. You can see us still in the corner.
Member who is undefeated.
I want to see if they show our sad faces in this.
Yeah. So, Andy Grady, who's the announcer in this, is talking through there's an undefeated team on the field in Team 694, and they're not moving.
They are not moving that box from the get-go here. Oh, this could be disastrous for StuyPulse. Finally, they get moving.
Yeah, that was the weird thing. We did start moving.
Yeah, so this match we do move. And I remember the electronics plate comes off almost immediately. So it's everything's going wrong.
Pulse unleashes in that red trailer.
I just remember us. You can see the panel.
Joe, can you turn the audio off? I'm having trouble hearing you.
Okay. I just remember us as a unit being okay, I don't care what happens. We're not losing this match.
Yeah.
and just like willing ourselves through it. Like the match has started. We're almost halfway through it. Our electronics panel has come off because a ball got in there. It's now stuck between us and the trailer, and I can't see it because it's Lexan. But like,
You can
Joe's
see
like,
me
turn the other
biting
way
my
to get it off.
fingernails.
It falls to the ground. It's just in the middle of the field.
I remember that.
And then it's just like Joe just takes control of the situation. He's like, all right, go to the human player station, load up. And we just like got back into the rhythm of things. I'm trying to turn up the volume just a little bit because you can't
go for
see
it.
us, but you can hear the description.
The volume on the video is much higher than your volume.
Down to the minute mark in the round.
I turned it down.
RoboCat's trying to accumulate more moon rocks. StuyPulse starting to get a move on it. Very exposed electronics on the back of their robot. StuyPulse, like I said, trying to gain some ground for the Blue Alliance. Here they go. Pushing in. There goes 2, 3, 4, 5, and now filling the whole goal. Good job by StuyPulse.
Yeah.
2060.
There were two weird things I remember about this game, Joe. I said two, but now I can only remember one. But they try. I mean, you could see from this thing that they're trying to keep score during the match, but it was very hard. So you didn't actually know what the score was at the end. You had like an idea, but it wasn't always true. So they had to like go and recount everything. And so there were a couple matches where it didn't match, and the outcome was different.
Yeah, real-time scoring was just a guy at a panel guessing.
I mean, imagine trying to real-time score this. This is really hard. Like,
yeah, it's impossible. I mean, nowadays it's like they automate a lot of the things. They try to make the games run automating it, but it was impossible in this game.
Yeah.
You can see our panel in the middle of the field in this video. I think is really
with the logo on it.
Yeah, with the 694 logo on it.
Those moon rocks into place. StuyPulse facing some hefty resistance from the Technobots. 20 seconds left. Time for the Supercells.
Hey, you see that shot that Johnny just hit?
Yeah, I did. He got another one. Man.
Like, Johnny's just in this whole front. He hits like 3 or 4 shots just in 7-4-3 as they're defending us. And they're just like, it's not just that they're in, they're like perfect shots.
And they're fast. It's just like one after another.
20 seconds left. Time for the Supercells.
Effortless.
The way out. There are no empty cells in the waiting though, so it looks like it's just going to be normal scoring maneuvers here in the final 10 seconds. Running on down to 3, 2, 1, and time expires.
Yeah, so that was a huge match. We end up. I remember after this match, Team 1100, who was the 1 seed coming out of day 1, coming up to us and being like, "If we're the 1 seed at the end of this, we're going to pick you," which to me was like the biggest whoa moment because 121 was there and they were incredible. They went to Einstein later that year. They had won the.
They had the denim conveyor belt.
Yeah, they went to the Granite State Regional and won that in week 1. They were so good. They were also a powerhouse just year to year. And the idea that we could get picked over them was unreal. And we really wanted to play with them. So we go through quals. We go undefeated. 121 goes undefeated. And 121's like the 1 seed, and they say, "We're going to pick you." Terrific. Great. But
I remember how good that felt.
Yeah, that was awesome.
Oh
that was the first time our team had ever been on the number 1 alliance. Well, actually, no, 2007 we weren't, but we were the second.
Yeah, it doesn't count. It doesn't count.
It really doesn't count.
We were third pick.
Yeah, exactly.
Not the same.
So they say they're going to pick us. And then I remember this crazy thing happening where one of our matches gets overturned, like our first match of the day from the day before gets overturned for some reason.
Yeah,
we ended up getting a loss. And I was like, well, this is what? We won that match. And this is the weirdest overturn ever.
Yeah, I was looking at that.
So I want to mention this because this is actually like a really important story for talking to referees and all of that stuff for the kids watching this. If you note, the score is 57-55, the final score after the adjustment. So this wasn't the original score. This was after the adjustment. You can only get an odd score by scoring a supercell. Every other scoring in the game, penalties, moon rocks, it's all it's all even. So basically a score of 57-55 means that both teams scored a supercell. So if you watch the match, I don't know if I want to play the whole match, but essentially the other line scores a supercell, like at the buzzer. Something weird happening. The other line scores a supercell at the buzzer. I wonder if it's in the video or not. And then they convinced the referees through like a video replay. I think it's actually, let me do it.
Gonna have to go long distance. 2, 1, shot is up. What a shot! 3/4 of the way down. Just looking for a good opportunity.
The other alliance has a supercell in the waiting.
He's gonna have to go long distance. 2, 1, shot is up. What a shot! 3/4 of the way downfield.
Right. So we still won the match despite that. And then 177, who was one of the best teams in first in terms of performance. They've been on Einstein like 4 straight years. Although they weren't, I wouldn't say like they were one of the top robots. They just like happened to be on a bunch of alliances, like as the second pick often. But they convinced the referees, and they showed them a video replay, which is not allowed, and was not allowed, I don't believe, back then either, of the shot being after the buzzer, and then somehow convinced them that our alliance was the one that shot it, so we've lost 15 points.
Really?
Which is why we ended up with an odd score. So they got credit for that supercell, and they took off 15 points from our alliance.
Okay, so I remember this, and I remember. Yeah, I kind of just remember we decided not to contest because 121 was still going to pick us. Is that right?
Right. But that was nonsense. We should have contested. But
it's totally nonsense.
I mean, experience just taught me like it's valuable. Just if you think something's off, just arguing it, because they'll even overturn things that are wrong sometimes. So if you have any ground to stand on, you should talk to a referee.
Yeah, I remember. I mean, I don't know if you talked about this, but we were arguing with the referee in 2008, and he literally felt bad that he wouldn't overturn it, and he cried. Do you remember this? He was this old school. He was a really nice guy. I can't remember his name, but I remember him like holding back tears because he couldn't make this decision for some reason.
But I also think it's important to understand the rules at a high level so you can make these arguments well. Why it's like I always make sure that I have a good understanding of the rules, and whichever driver is going to talk to the referees has a good understanding of the rules. But this one.
Oh, you know what I was going to say?
Yeah.
This was like 10 minutes ago, but I realized one of the funny things about this game was that, you were the driver and I was the operator. Being the operator in this game was like a very easy job. The acquirer was running the whole time, and I really had one job, which was like shoot the balls when Joe said shoot the balls. I don't really have anything else on that, but I'm just thinking back to what it meant to be the operator on this robot.
But you're also like a secondary coach, like.
Yeah, sure. Yeah, I mean, I'm happy to take as much credit as you'll send my way, but.
And if like something was wrong and you understood the robot at a high level, but we didn't have any issues in terms of mechanical, luckily. So we go through quals, we're undefeated. We started having some weird issues with autonomous during some of the quals matches. At the end, we're not really sure what's going on. It's just not, the autonomous is just not working, even though we didn't change the code or anything.
We were worried about it because I spent a lot of time talking with the lead field tech. I can't remember her name. It was a really nice, helpful woman.
Sabrina.
Who was Sabrina, you're right. And she was from National Instruments, I think.
And she didn't really know what was going on.
No, but she tried to be very helpful, and it couldn't fix the issue. And it was intermittent, and it was like we wouldn't move during auto, but then we'd come back on like a few seconds into a match.
Yeah.
All in quals.
Yeah. So it wasn't through all of quals. It was just like on that last day, and there was maybe like one match in New York where it happened.
Exactly. It was only the last day.
And then so we go into a limbs. 121 picks us, and I remember I went out there for a line selection, and it was I think that was a really big mistake on my part. I was director of strategy,
Why?
So I went out there. I'd studied the field in advance, but I was so in the weeds with match prep, I hadn't really, and just like being in the zone for the matches and getting ready for the matches. I hadn't watched enough matches. And Sam Unger really knew the field really well. And I remember when we're going out, 121 wanted to pick Rage 173.
Rage.
To me and you was
they gave me a t-shirt that year. I still have it.
Yeah. To me and you it was that's fine because they were always a great team. Their 2002 robot was one of the best robots ever at that time. And had been a big inspiration to both of us. So I was like, okay, that's fine with me. Sam was like,
I remember being excited to be on their alliance, especially to be a higher pick than them on the alliance.
Right. And then Sam was like, they're not good. We should not pick them. We need to pick 237 if they're out there. They're awesome. We need to pick. She put out 5 teams that we needed to pick over them, and she felt like one of them would be available. And when we went out there, I believed her. She'd watched the matches, I hadn't, and I'd argued the point. But I think it was a mistake not having her out there because I didn't push very hard. I made her argument, and then I kind of moved on from it. And I felt like she should have been out there making the argument. There was no point in me being out there. We knew we were going to say yes. There wasn't any kind of on the fly thinking. She needed to be out there because she understood what was happening in this field, and I didn't. And I think that was a big mistake. 173 was not good in elims. Their human player committed a penalty almost immediately in quarterfinals. They did not have their stuff together. And 237 was awesome. I reflected and I watched back, and 237 was really good. And Sam really wanted to pick them.
You think it would have made a difference in the end?
If we had picked them, or if she was out there?
If we picked them, presumably.
I think it actually.
She'd been out there and we picked them. Do you think it would have made a difference?
I think it would have because they could really score, and they were the only teams doing the empty cells. They really fit our alliance well. I think we could have won if we had picked them, even with our issues. So I try to, apply that to other directors of strategy, going forward, is telling them this story and saying, it might not make sense for you to go out there. It might make sense for someone else to go out there. So if we know we're going to be the number 1 captain, I like to tell the director of strategy to hang back so we can all make the decision together in the stands. If we don't know what's going to happen, it's important the director of strategy be out there to talk to whoever we pair with. But yeah, Sam definitely knew the field way better than me, and she should have gone out there. We ended up picking 173, and we felt good about our chances. We come out to our first quarterfinal match, and we don't move at all.
At all.
Yeah. And it's just what is happening? And our head of software, Jordan, has been kicked off the team. And I don't think he was there, right? He was sent home.
Yeah, I think he was sent home.
And it was over, he was, actually his was even more because he wanted his girlfriend to come, and he said he's not going to be here if the girlfriend doesn't come, and he went home because of that. There was also a layer of that. I remember being really upset with him because it was just so selfish.
Yeah.
We'd worked so
he
hard.
He felt really bad about it, but didn't really know how to express it, as I remember.
Yeah. I never, I wasn't a huge fan of Cologne, but I never blamed him for that situation. He
did the right thing.
Yeah, he did what he had to do, and I was just mad that I felt like the team was not. They weren't helping out the team with what they were doing. But Ariel really tried to do whatever he could. I remember Ariel really stepping up and trying to figure out what was happening and doing all he could, but he was just didn't know enough yet. He was sophomore or freshman at the time, sophomore, I want to say. And it was his first year on the team, in his second year. He really didn't.
He must have been a sophomore, yeah.
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 So he didn't know how to fix it. We had 121's software mentors.
And to be fair, not to jump ahead, at the end of the day, it was a problem with the field system. You remember they announced this 6 months later. So there wasn't a way to fix it.
Yeah. The real issue though, is I think that I think we determined was the timers that we had in our program.
Yeah, there's something we could have changed that would have fixed it, but it wasn't an inherent problem. It was how a reasonable thing interacted with a flaw.
It was a thing we were utilizing that other teams weren't utilizing that was failing. And it wasn't we did something particularly wrong that made it fail. It was just like it wasn't there. So we didn't move in the first match, and we come into the second match, and we don't move in auto. I'll play the second match.
3, 2, 1.
And I'll just do the audio for a little bit because you can see, like, the audio tells a story.
Oh wow, the video on this is a lot better.
I uploaded these years ago onto the YouTube channel. Like, I pulled it down. Blue Lions used to have a very different website. So the field was so messed up because the timers weren't going right on the field and the buzzers weren't going right on the field.
It looks like, once again, StuyPulse not moving.
No sound. How we have to start it. No sound. No one's moving.
Drivers take control. Looks.
So it's almost 10 seconds to the match. No one has moved because no one's heard a buzzer. But if you listen closely, you can hear the moment when our robot starts moving in this match because the crowd goes like wild. You can actually hear it.
Drivers take control. Looks. And now back with a vengeance is the Red Alliance.
Right, we play like crazy hard in this match. This 8 Alliance is actually really strong. But
121 a sitting duck now.
we were just like really coming alive. And, like, now 121's not moving. Like,
Birds of Prey holding them
come
down.
back to life.
Playing good defense here. StuyPulse getting loaded up and ready to go. Road Warriors now pushing into 181.
And
They're going to try to find an open goal.
Oh man, I remember that 173 robot. It really wasn't very good.
Their human player committed a penalty in this match. We were on the brink of elimination.
Yeah.
We barely scored.
StuyPulse trying to find the goal to unleash him. There goes StuyPulse in the blue trailer. 121 now has a full load. They're ready to go. Ace is hot.
We both used to be skinnier, Joe.
I know.
I'm watching
these
videos
is
now.
pretty rough.
I know.
Seeing some of the photos
And
is
all of a
bad.
sudden, Red is
Yeah.
game.
Some improvements, some
StuyPulse
not.
more.
I can't believe they had the denim conveyor belt.
It worked so well.
It worked so well, and it was
Getting
felt silly.
misses.
Yeah. I mean, this roll was awesome. They
Ace
had
is
that
trying to
curve. They
find somewhere
unloaded the
to
ball
score.
so fast.
StuyPulse.
Yeah, they were really, really good.
They score again. 121 picking up more. Pussy Tech's trying to make something happen here. 121 scoring again. Road Warriors now trying to find their next move. Ace is high picking up more. Supercell ends up on the blue area and top is on the rack.
So we barely win this match. We barely win quarterfinal 3. Quarterfinal 3, we don't move in auto either, but we get to semifinals. We don't move in auto in semifinal 1, and we lose that match. And then between semifinal 1 and 2, you know, Ariel and the people on 121 who had been working on fixing the problem had basically coded an auto that just went forward. Because the problem was, if you don't move in autonomous, yeah, you miss out on loading up and everything, but the bigger issue is you're sitting right in front of your opposing human player, and they're just loading up the trailer with the balls they start with, which is, you know, a big problem. Not moving auto was a big problem that year. So they coded that, and something went wrong, and they basically ended up with no robot code when they tried to load the code. And we were stuck with it. Yeah.
I remember this a little bit differently. I don't remember that they screwed up our code and that's why we didn't run all match. I thought, is that how you remember? I mean, I could be wrong here.
So I don't think they didn't screw up our code. They just, like, were trying to code something on the fly to make us move in autonomous. I wouldn't call it like a real screw up, but yeah, when they loaded the code, we basically had no robot code. And I remember coming onto the field, they're like, it's not going to move.
No, oh wow, I really don't remember that. I mean, it's hard to.
I remember vividly like being told, like, when we were going on the field, like, the robot's not going to move, no matter what we do. And when we, you know, it didn't, and that was it. We sat there in our final match and we didn't move. And I thought about, you know, that match. I like looked back on it And I felt like we just shouldn't have even gone on the field if we knew it wasn't going to move.
Well, so it's funny because I totally remember it differently, which was, and who knows, I'll tell you what I remember, and it might be wrong, but I remember that it was just a manifestation of that same issue. It wasn't that we hadn't loaded code on the robot, but it could just be that I misinterpreted the scenario. I mean, we'll watch the match. It's going to suck, but because I just remember us behaving like we expected the robot to work.
And it was like
controls.
I think it was like I just didn't want to give up. So it's like on the sticks the whole match. In fact, when we were loading the robot onto the field, Johnny and I almost dropped it. It like started to tip over, and I caught it with my face.
See, look, we go right up to the controls.
No, but like we going in, if we notice the FTA is talking to us, and we like kind of we go up and we know something.
Oh, that was her. That was Sabrina, right?
Yeah.
All right, we don't have to watch any more of this.
But it was really rough. That was kind of the end of it. We played so well, and that was like the end of the season. It was really heartbreaking, but that was a really great season. We did really well.
It's funny. I still remember the season really fondly. Like I remember that better. My memories from that season are better broadly than the next season where we won the New York Regional. But I just didn't think we had as good of a robot.
Yeah. I mean, this was, I think, in our history, it's the third best robot we've built still. And
what's 1 and 2?
I think
to me, this is the best robot we've ever built.
Yeah. I think the robot we built in 2018, the one we ended up with, was the best robot we've ever had. It was really one of the best in the world. And then our 2020 robot that we just had was the second best one.
And who knows? It might have been the best.
Yeah, who knows? Never lost a match. I don't think it was the best robot in the world. It had limitations, but it was really, really good.
To this day,
this robot was really like, if we participated in this game again, conceptually, it's the robot that
you wouldn't change a thing.
I would change a thing. I would change the drivetrain. I would add more wheels to traction. I would lower the center of gravity. I would change details, right?
Sure.
But the concept is perfect. There are major changes you can make to the concept to up, hopper capacity. Yeah. But I think I think it's not worth the cost, the price of simplicity.
All right. Well, I was going to say it's just to this day my favorite robot of all time, not of our team.
Period.
Our team. This is my favorite robot, just because afterwards, I feel like you could guess this. I want to give you a guess, and we'll see if you're right.
What, your favorite robot of all time?
Yeah.
It's 11/14/2008. It's easy.
Yeah. It's such a perfect robot.
Steven and I talked about that robot and your love for it for like 10 minutes in the last episode.
I could, if you asked me today and you gave me 6 weeks, I on my own could rebuild that thing. I could make a carbon copy of it. I remember the parts. I remember how they did everything. It was such a great robot.
But so
there was no other robot like it. It was very unique, and that was stunning to me because it was so dominant and nothing was like it, or at least nothing was nearly as good as it.
So in 2014, there was a similar game to 2008, and a lot of teams copied that robot.
Did they?
Yeah.
Did they do a good job?
They did an okay job. 11/14 actually did a similar looking robot, and they were really good that year. But instead of using a puncher, they actually powered the rollers even more so that they can shoot the ball. So they basically turned the roller.
Oh, I remember seeing that. Yeah.
But going back to this robot, it was really terrific. For those of you who don't know, there's the term OPR, which means I think it stands for offensive
power ranking,
something like that. And there's CCWM, which is like calculated contribution to win margin. There are all these great stats. There are all these great things that are used to, rank teams. And it was definitely flawed in 2009. But it did, indicate who some of the best teams were. And our performance at Connecticut was number 1 in CCWM in the world for anyone.
Yeah. It wasn't flawed. It was perfect.
Our OPR was like top 3. It was, it was really, we played incredibly well. I was very proud of that year, but I was also obviously very upset that we didn't make it.
Yeah, because
and that we came up short, and we had a chance to win.
Before that year, I mean, like, I can't speak as much to the history like post 2010. I pay attention, but not nearly as with the same like attention to detail. We never had a robot that felt like if we'd gotten to nationals, we could have really competed well. Like, we had good robots, but they weren't nationally competitive. And this robot felt like if we'd gone to nationals, we could have competed really well.
Yeah, there were robots who were just as good, if not worse than us on Einstein. Plenty of them. And we were, when they did like their cheap Delphi thread about who are the best teams not at champs, they always.
Karthik said it was us.
I think Karthik loves us because he always talks about us ever since then. But a lot of people talked about us as the best team, one of the best teams not at champs, and that was nice. But it's still, I do look back at this and think that I think that if this hadn't all happened, and that if we had won Hartford and gone on to champs and had a really great showing and whatever, made it to Einstein, didn't make it to Einstein, whatever, had a deep run, I'm not so sure I would have come back to mentor.
Really?
Yeah, I was so distraught about this. I was
because you were a senior this year. This was just my junior year.
Yeah, and maybe I would have come back anyway. I really loved robotics, but this definitely kind of motivated me to come back.
You were hungry.
I was hungry, and definitely when I first started mentoring, it was almost like an extension of being a student, and then I kind of over the years grew into more being a mentor. But I don't think I would have become a teacher. It's like a huge domino effect from this. So I'm thankful in a way for this, but not really. It sucked. Let's jump into.
That's how I feel. That's how I feel about the fact that we couldn't build the 2007 robot in the lab, which was terrible. It like ruined our season kind of. But it meant that I ended up getting to work with the core team at Cox as a freshman, which like definitely made me way more involved. And I think without that, I would never have been as involved. Or who knows? It's hard to predict like alternative timelines, but that's definitely a big one for me. And to everyone who was listening, I guess last week or maybe the week before, whatever cadence you're doing the set, that was like very much thanks to Sammy, who really encouraged me to come to Cox and work at Cox and be involved, and Poe as well. Older Poe, Paulina, not Joanna.
I don't think they know either of them. Yeah, I wanted to get Poe on.
Well, you got to study up.
I'm going to get the other Poe for 2013 or 2012.
I'm sure Poe would be happy to. I haven't talked to her in a long time. I think she's at SpaceX also.
I don't know. I think so too, actually.
Yeah. I'm gonna
older Poe. Older Poe. But the season we lost. We didn't qualify for champs. We only won. We won the entrepreneurship award at Connecticut. I think it's we walked away with the least awards we'd ever gotten for a season. Yet it felt like it was our strongest year, which really sunk. And kind of aside to that is our marketing team was starting to get really good. We won Engineering Inspiration the year before, and they really put in a ton of work this season, and it wasn't super recognized. I even felt during awards that we had a shot at Engineering Inspiration because we were doing so many outreach activities. We were doing Lego League stuff. We were hosting tournaments. Every weekend there was something. We did we ran a blood drive. I think is that right, Seth?
Yeah. Just for the record, old Paulina still works at SpaceX. She's been there 8 years. I just friended her on LinkedIn.
Cool. So we have her, we have Betsy, and we have, I think, Alex Curlo is still at SpaceX.
Really?
Yeah. Oh, he might have left. I'm not sure. Anyway, so 2009 season comes to an end, but we ended up going to Monty Madness as our off-season event, which actually doesn't exist anymore.
Yeah. And
I remember to me it meant a lot that we went. You guys, we could have done it where you drove and just I don't know, I coached or I wasn't really involved, and we got Adam to operate or something, just doing next year's. And I remember it really just meant a lot to me that the team was even Cologne was want you to drive, get another chance at it.
Yeah.
And that was really great for me to get that opportunity to go again. You made that change to the shooter, and we were much better in terms of unloading, but we didn't play really.
I can't remember what happened at that, honestly.
We weren't known. Like, the New Jersey teams didn't really know us very well. Like, we'd been to Trenton, and we weren't great.
Yeah.
And we'd never gone to off-season events, so these teams didn't really know us. So we were picked. We weren't picked. We were just an alliance captain. And then we kind of just, I don't know. The off-season events are always just like a crapshoot.
Do you remember – and also, you don't – there's like – I don't know. At least I didn't feel the same like kind of drive to win. The thing I remember about that event, and I can't remember exactly how this came to be, but 2753 – that team that went to Einstein that year and was just really amazing, let me coach them one match. And at the end of the match, they were like, we can't, like, we've never had anyone coach us like that. That was so great. Our coach just kind of would stand behind us and do nothing. Like, that was so helpful. And I was like, yeah, that was great.
Yeah. That was really great. It sucks that I remember us wanting to play with them there, but it didn't really work out. But it was, it was just nice to get to play again and work as a team. I remember there wasn't a big turnout for it, which was very disappointing to me because we'd never been to an off-season event before. We had tried a lot to convince Cologne.
Didn't we get into IRI that year, but we couldn't. We weren't allowed to go.
So we weren't allowed to apply to IRI. They didn't even let us. 2010 we applied and they didn't let us go.
Yeah.
But. It was it was like we convinced them to let us go to this off-season event, and I wanted there to be a big turnout so that we could convince the teachers that it was worthwhile, that students wanted to do it. And I remember going like student to student, like, are you coming? Why aren't you coming? We need you to come. Support the cause. And I think like 10 kids came, and which kind of sucked. But.
Yeah, I also don't have like not bad memories. I just like it wasn't very memorable.
Yeah.
It didn't feel that exciting.
Yeah, so that kind of was a letdown, but it was nice to get to go there again. It felt like me, you, and Sam were just like running things, and it was a good time. And it was the first ever off-season event we went to, and it did a little bit get that ball rolling on going to off-season events. We kind of still went to some, didn't go some years, but now we go to a lot, and I think they're great opportunities for learning. Let's see if there's anything else from the postseason I wanted to talk about. Let's just talk about like some lessons learned. What do you think about the season? What big lessons do you think we learned that you would want to share with the younger kids on the team?
Yeah, I mean, from like an engineering, maybe, I don't know, I guess a couple things. What I would say is that you see that like Joe and I talk about this season so fondly, even though it was like super painful to lose at the end. And I still like think back on this season more fondly than I do the next one where we did win a regional. I don't know exactly the point I'm trying to articulate, but like in the moment it feels terrible to lose. But 11 years later, you'll feel more fondly about it, maybe. But I guess it's not all about winning. I think from a technical standpoint, like sort of twofold. Something that was really good about this robot was that it was very tolerant to like driver sloppiness, right? We made the acquire as wide as possible, right? You just had to kind of get in the right direction and you were good. The acquire corralled the goal. All of these things made it easy to do well under pressure, to do well when you couldn't see very well. So making something that is tolerant to driver error, which is inevitable, is great because even the best drivers are going to suck sometimes. And finally, I mean, I thought you were pretty good. Get out of here. Even, what's the last one? I mean, this is like, everybody says this. It was said to me my first, right when I got on the team, but like, if you can come up with a concept that is good and an implementation that is simple, that is something that will serve you well, like in first robotics and engineering always. I am the guy on my team now who probably to a fault always asks is this too complicated? Can we make this simpler? Do we need to do this fancy thing? Anytime you add complexity or you tie systems together that don't need to be and create dependencies, anytime something is confusing or complex, it's just less likely to work well. Like you should really strive to only add complexity where the benefit outweighs the cost. And this robot was really simple.
Yeah.
That's why we built it so fast. That's why it never broke. Yeah, I think those two things, like make something that's easy to drive, make something that's simple, and simple in a robust way. You have a good
when I look back on this season, I just, we were really a team. It was like it was a smaller group that year. There weren't a lot of seniors.
There weren't a lot of seniors, yeah.
But it really felt like we were a unit, no matter what direction we were going to go.
And we had a lot of really engaged sophomores as well.
Yeah. And, even though you were younger than me, you're my leader. I'll trust you, whatever. Let's do this thing. And I didn't really know what I was doing. And you trusted me, and that meant a lot to me. And I feel like that's a really good lesson in leadership, is just, you show people trust, and they'll do good things, even if they don't really know what they're doing.
That's a great takeaway. It's really easy to feel like you know everything, and to micromanage, but it's almost always a recipe for holding good people back.
Yeah. And then I personally learned a lot of lessons about just strategy, because the year before we were up there in the rankings, but we weren't looking at the number one lines ever. We were looking at 3, 4, making a run, trying to upset. But here
we were excited to just be in the top 8.
Right. Here we were really looking to be one of those top teams, and we weren't really ready for it. So big takeaways I had was, put the person who's running strategy on top of things, even if you have the position. If they know more than you, let them trust the people under their expertise. And I feel like I should have trusted Sam more there. And then
I thought Sam was really an all-star that season. It was not I think that the team now has a real emphasis on strategy, but it wasn't for lack of a better word, revered position back then. And she did a really good job and was just very thorough, did a lot of work, and then did the next year as well.
Yeah, and the year after that.
Yeah, that's true.
Her sophomore year. Yeah, she was really fantastic. Really great second. I wish looking back that I had trusted her more than I did. And I think there's just a lesson in there about trusting, in leadership, just trusting people below you. And I think our strategy team does a really good job of that now.
Mm-hmm.
And another strategy lesson I learned was if you're trying to get that 1 seed, you need to play to the tournament schedule, the tournament system. You need to know the tiebreakers. You need to play to them. You can't be the top seed if you're going to be super conservative. You just can't. You have to be aggressive. You have to go for whatever that is going to get you that extra ranking point. It's going to get you that higher seed. You need to talk to the referees if you lose a match. You need to talk to the if there's something wrong, you need to talk to the referees. You need to look at your alliance and make sure they know what's going on. Because that coach button thing, yeah, they fixed that rule, but there's other rules like it. And today,
and there are human players that cause penalties, in elimination.
Right, that shouldn't happen. And 173 is human player. It's 173. They've been world champs. They're going to be fine. They were world champs 7 years before this. They're going to be fine. Their human player's not going to commit a penalty. That's what we assumed, but that was wrong. Nowadays we have members of our drive team who go through and talk the other drive teams through the rules and make sure they don't commit any penalties. So we started implementing that in future years, but sticking to that and realizing why it's important in seeding first is something I really took. Yeah.
Do you know that I have this?
Man, that looks familiar.
As you can see, I keep this right next to my desk. It's hard to see because it's clear, but this was given to us by Team 20 that year for Best Designed Robot. And I took this with me to college, and then I took it. I still have it. I remember being given that and thinking, I was so upset because we had just lost. We'd just gotten out, and they gave it to me as clearly for the team. And I was like, I'm taking this home. I want it. It's going to be mine. And I don't regret it because I still have it, and I still cherish this award.
Well deserved.
Thanks, Joe.
All right. So let's let's move off of FRC stuff and kind of, I want to ask you some questions, Seth.
Sure.
First off, I was hoping you could talk a bit about your college experience for the students who are about to go to college and who are looking to what colleges they might apply to in future years, in the coming years.
Yeah, so it's funny. I was trying to think the other day, like where, like if you'd asked Seth, freshman high school Seth, where he wanted to go to college, I don't think I'd have known. I don't know what I would have said. But when I saw Steven, who was 2 years ahead of me, get into and go to MIT, it was like there was no other option for me. Like I knew that that's where I wanted to go. I don't know if I've ever told you this, Joe, and I'm going to preface this with, don't do this. This is a terrible idea. And I can't believe I did it in retrospect. But I knew I wanted to go to MIT. I knew it was my top choice. So I applied to like one of my safety schools before that. And I applied to MIT early. And the MIT early apps or like responses came back like December 15th or like December 7th. And every other, like the common app was due like 2 weeks later. I hadn't filled out a single part of it. And it wasn't because I was cocky. It was just because I was like, I don't know. It was like I was not motivated or something, but I didn't fill out any of it. And in retrospect, that was like, it's a really terrifying thing to have done. And I was very lucky to have gotten in. Don't do that. Do all of your apps ahead of time. I spent a huge amount of time. And it's funny, I was going through emails before this and seeing the like literal months of revisions I did to the essays for that application. I don't know what the takeaway here is. Be more prepared and don't leave things till the end, but spend a lot of time on your college apps, I guess. I don't know.
Maybe this is,
so I ended up getting.
So like my takeaway from that is you're just like, I'm going to MIT. I'm not going to apply anywhere else. No safety net.
I don't know. No. I mean, it was bad because I would have been in a real bind if I hadn't gotten in. But it felt like the right place. I knew what I wanted to do, and I suppose I get this, but like I knew I wanted to do mechanical engineering. I wanted to do MIT. I respected Steven. I thought Steven was like the coolest person ever. So I wanted to go there, and I did. And when I got there, I ended up living with Steven and staying, best friends with Steven to this day. But I guess my story at MIT is that I went in convinced I was going to be a mechanical engineer and taking mechanical engineering courses until my sophomore year summer. So the summer after my freshman year, I interned at DECA actually, and it was awesome. It was such a fun internship. I was just like one of the mechanical engineers on their team. We were developing a product that to this day has not shipped actually. So it's been 9 years since I worked on it. But it was a home hemodialysis machine. Probably not worth getting into the details, but basically like a pretty complicated medical device. And I got to do all this sort of design, and I loved the team, and it was fantastic. And then summer of sophomore year, I got offers at Xerox to go work at Xerox. And I got offers at this like cool biomedical startup making exoskeletons. And then also at Formlabs, which is actually where I work now. And I was like, I'm going to go to Xerox because they're paying me more and they're a name that everyone knows. And it was terrible. It was the most boring internship. The work was boring. Everything was boring about it. I didn't get much done. I was like in the suburbs of Portland with no car. I had no friends there. The whole thing was miserable. And over that summer, I decided that mechanical engineering is not what I wanted to do. Probably it's like an overreaction to a bad internship. And so I switched my degree to computer science, but I took a bunch of electrical engineering courses as well. Then the next summer, I had another absolutely miserable internship where I was writing like driver software for enterprise storage systems at this company called NetApp, which again was like a decision to work somewhere with a big name that paid me a lot. That was really, really unfun, and I should have realized I wasn't into it. And then this all has a happy ending, I promise. But then I decided that I was going to stay around and do a 1-year master's. And the thing that seemed like the really buzzwordy thing that was going to, make me a lot of money was machine learning. So I got my way into this lab, and I was going to do a master's in machine learning. And literally between my last class and graduation, I was supposed to be starting this lab a few weeks later. I realized that it was really not what I wanted to do. And so I bailed on the lab, and then I ended up starting a company with a friend of mine. I can like go into the rest of college, because there were like lots of things I did in college that I loved. I guess sort of what I'm circling here is that like you shouldn't make decisions based on the things you think are like the most exciting or like sexy jobs, or the things that are going to pay you the most, because if you don't like doing them, none of that is worth it. Like when I think back on those two internships, like working at Xerox, it was just like every day was boring and miserable. And same thing at NetApp. Compared to what I do now, which is like I'm really engaged all the time. I work all the time because I want to. But so I left this master's program, although I think it's still technically on hold. I haven't talked to the MIT administration in a while, but I might be able to go back if I wanted to.
How many credits did you need?
I think I could do it in a year. I would just need, yeah. I mean, it was like MIT does these like 1-year master's things that are pseudo masters, but a friend of mine from college, a guy I'd lived with, had gotten this super bad concussion and had just kept wrestling. He was on the wrestling team, kept wrestling, and had this like very serious head injury. So he was like, I want to start a company to build head acceleration monitoring.
This now.
Yeah, and it was
Ben,
good,
right?
good idea. Yeah, Ben. Yeah, you know Ben. It was a good idea. And I did that for a year with him, and basically he was the CEO, did all the business stuff, and I developed the whole product. I did a ton of the electronics. I did all the software, like firmware from ground up, the injection molded parts. I also planned our Kickstarter campaign that we ran successfully and raised over $60K. Excuse me, get the cups. Ooh. And like most startups, we weren't able to raise enough money or like sell enough products to really keep the company going, or certainly not to justify like developing more technology. So I left after a year of that, although we did ship to all of our Kickstarter backers. And as I was driving back to Boston from Kansas City, where we were based, my car air conditioning broke down. And so in the Subaru dealership in St. Louis, I messaged Ian Ferguson, who was Tom Ferguson's son. And I guess a part of the story I didn't tell is that during one of my semesters in college, I interned at what was then a very, very tiny 3D printing company called Formlabs. I was like their second intern ever. They had like 4 employees. And at this point, yeah, Ian was one of them. That's how I ended up there. So Ian was the first engineer hired at Formlabs. And now at that point, they had about 100 employees doing really well. So I messaged him. I was like, hey, I need a job. And it took about 3 months. So I spent that whole summer without a job. And it was the summer my girlfriend at the time, it was after she had graduated college, before she was going to law school. So she was just taking a summer off to hang out and relax. And I did a bad job of applying to jobs. So I only applied to 3 jobs that summer. And 2 of them were where Ferguson's worked. So one was Ian at Formlabs, and the other was David at Uber, the Uber self-driving division, and then one other company. But then right, like the week after Erica flew down to North Carolina to start law school, I got this gig at Formlabs on, actually starting as an intern. They were like, we'll hire you as an intern, and if you're any good, we'll bring you on full time. And I was on this like little R&D team within Formlabs that was working on a secret project. So Formlabs builds stereolithography printers. It's a 3D printing technology. I think you guys have some Form 2s that uses photocurable resins and ultraviolet laser and scans cross sections layer by layer and build 3-dimensional parts. The team I was working on wanted to do the same thing they'd done for this technology, which was take a unapproachable industrial technology that was really expensive and make a accessible, easy to use product that was just as good. So the goal of this team was to do the same thing with a different technology, which is selective laser sintering. If I'm not mistaken, Joe, you don't have any SLS printers at Stuy.
Well, I think I wonder if the metal printer does use, no, it doesn't.
No. So
SLS usually
part of the reason we're doing what we're doing. Yeah, nylon it's like 98% of all SLS prints are nylon. But the gist is this technology typically costs like $250,000. It's very hard to maintain. You need a service contract, but it produces really, really mechanically, for lack of a better word, awesome parts. They're ductile, they're strong. And so we set out to do the same thing, right? Take this technology that costs hundreds of thousands of dollars to use and make it, our price point was $10,000. So I actually only have one sample part at home, but this is off one of the printers that we make. So it's a little hard to see.
It's like,
this is not an ideal
video, so it's recorded, so everyone can see it in the recording. Yeah, I can see it.
Sure. And then you can see here the part is really ductile. It's got a lot of bend and flex to it, but it's also really strong. Actually, can I share my screen? I'll show you some
Sure, I made it so you should be able to share your screen.
Okay, let me just bring up the right things. Bear with me for 1 second. I have like a million browsers.
All good. I think while you're loading that up,
Go ahead.
I
I just talked for 10 minutes straight.
No, it's okay. It's okay. It's great. I think there are a lot of our students and even mentors who are interested, because some of our mentors are in college and they're not sure what they're going to do next, and some of our students are about.
I have no idea what I'm going to do next, just for the record.
Yeah. Well, I don't think any of us really do. But you got your job through FIRST, your first connections, and I think that I have my job through FIRST, and every job I've gotten in my life, I've gotten through some sort of networking. My first teaching job I got because one of my best friends was working at a charter school. My second teaching job, Mr. DW, who was my APCS teacher at Stuy.
He was mine as well.
Yeah, he hooked me up with this school, charter school. I was starting high school when I wanted to get my high school teaching certificate. It made sense for me to try to go to a high school charter school, and he set me up with that. I got my job at Stuy because of robotics, because I was at a FIRST event, and Michael Zigman, who was a Stuy alum and one of the higher ups at New York City FIRST, met me and said, "Oh, you're interested in a job at Stuy? I know the principal pretty well. Let me pass your resume along." And even though students and parents who were talking to the principal, that inroad was the one that really got the principal to be like, "Let me take a look at this Joseph Blay and see if I should hire him." So I think the importance of networking is, it can't be understated. And the FIRST really
and
helped.
Making real connections with people. Joe, turns out I'm gonna have to reboot Zoom to share my screen. So I'm gonna hop off this call for a second, reboot it, and come right back.
Okay.
And I can share my screen. So give me 1 second.
No worries. Yeah, and Howard's in the chat. He's saying the same thing about that. I'll pause this.
I think, let's see if the screen share works.
All right.
All right, so
go ahead.
we got a video up, but really the thing I want to show is the wrong email. This is what we, where is it? This is what we show our suppliers, what we were showing our contract manufacturers when we were trying to find a contract manufacturer to build the printer. God, where is this? Sorry, I'm a mess all of a sudden.
It's okay. So I'll just continue my thought while you.
Yeah, keep talking. Sorry, yeah. I don't know where this is.
Yeah, so I think there's a lot of value in networking and making those real connections with people, where first you start with building a friendship, and then you make sure they know what things you're interested in, kind of your situation in life, and not being shy about sharing that with people, because they're going to think of you. If you're in their circle and they care about you, and they're going to think of you when an opportunity comes up. And the more people you network with, the more good opportunities you're going to get, because if you're interviewing someone, you have a stack of resumes, you don't know a lot about these people. If someone you trust tells you this is a great person, I know them well, you should interview them, I think they're a good fit. That goes a long way.
Also, I mean, I can say this with some comment, but like everybody really wants to help out and find you a good opportunity. And I mean, like same for me, right? Like you always want to help somebody find a good role either where you are or somewhere else. So I think you should never be, I found it finally. You should never feel uncomfortable like asking for help. If you think there's anything I can do to help you, I'm on the 694 Slack channel that I never post, so you can hit me up there.
Yeah.
Okay.
Yeah, go ahead.
I found this finally. Yeah, I think so. Here we go. Show my help screen. Can you see this?
Yes.
All right, cool. So you can see some pictures of the products that we make. The stereolithography printers are on the left, but what I work on is the product, this thing called the Fuse One, which is on the right. For some scale here, this is about the size of a mini fridge. Most SLS printers are really large, like fridge size or whole room size. You can actually, it's the wrong thing. There's a bunch here that is not about my product. So let me get to the stuff here. This is it with the door open. This is not my presentation, so I don't actually know what all the slides are. But one of the way that this technology works, and actually let me come back to this and first show a video, is it's a powder-based printing system. So you lay down a thin layer of powder, you heat that powder up to just below its melting point, and then you use a laser to sinter the powder particles. So there's all these tiny 60 micron about plastic particles. You heat them up to just below their melting point, and then you use a laser to selectively scan cross sections of your part. A couple of things really distinguish this technology, but one of the most interesting ones is as you can see here, there is some area that is not lased. And all of that unlased material acts as support for everything else. So if you're familiar with like an FDM print, you'll print out support structure for overhangs on your print. SLS does that by definition for everything. So you can print basically arbitrary geometries in SLS. And we have some very cool examples of like entire pieces of clothing that are printed in SLS with tens of thousands of tiny little chain links that are printed all as one because you don't need any support structure. And you can print sort of arbitrary overhanging geometry. What you're looking at here is about a 165 millimeter square bed area. And the print here is obviously like a huge, large thing. We're sort of stress testing the printer in this video. But I have another cool one.
How did you say it printed? You said 60 micrometers?
So the powder particle size is 60 microns. So that's the theoretical lower limit on dimensional on small features. We use a laser that is about 120 microns in diameter. You can, with some clever strategies, get features that are a little smaller than that, but 100 microns is about the lower limit to feature size, and layer size is a function of particle diameter.
And for the students who aren't familiar with that unit, so 100 would be a tenth of a millimeter, right?
Yeah, so there are 1,000 microns in 1 millimeter. So you can't see the part. I mean, the particles are like smaller than sand. If you stick your hand in the powder, it like coats your arm almost like it's like flour almost. A little larger diameter than that. I've got another cool video here. Let's see if I can open it. So what you're going to see here, I'm going to pause this for a second, is we have a camera inside the system, which is what you're looking at. So inside that mini fridge, there's no windows. There's a small camera that looks down on the top layer of powder. What we've done here is we've taken an image, every single layer, and stitched it together in a GIF. So what you can imagine looking at here is a three-dimensional part with a plane being dragged through it, looking at sliced cross sections, which I think is a pretty cool way to watch prints. And so here, this is one of the test prints that we run to those are tensile bars that you pull and evaluate the strength of. And then all of these, what you're seeing printed now are cones going up and cones going down. None of these are obviously like particularly interesting functional parts, but they're a whole array of things that we print to measure and compare dimensional accuracy in different feature sizes. And in reality, this print probably took around 36 hours to complete. So the build height is 300 millimeters tall.
So this plate is going down as you print, right?
Yeah.
As opposed to the Formlabs printers, which come up.
Yeah, I know I've not done a perfect job explaining this here. I've worked on this for 5 years, which is the longest I've done anything. It's longer than I was in high school. It's longer than I was a student in 694. So sometimes it's easy to just get right into the details. But yeah, so basically you have a platform, we call it a build platform, that slowly over the course of print moves down. So every layer, it drops down 100 microns. The top layer of powder is now 100 microns lower. You lay a new layer of cold powder on top of that. So you now have a 100 micron layer of cold powder. You heat that up, you laze it, it makes a slightly taller three-dimensional shape, and it drops down and it does that again. So at the end of the print, you have this bucket of powder and parts. And after it cools down, you excavate the parts, you brush them off. You can actually reclaim the used powder, and then you have the parts that come out in the end. And so what you're looking there is the bottom layer being printed first, and then every successive layer afterwards. I have two more cool, I think, kind of funny photos here. So this
is that Rick Astley?
Yeah, hold on, let's open it with Chrome. So somebody put this together recently. They took this video clip, they turned it into a GIF, then they turned it into a black and white GIF, and then for each frame of the GIF, they created the profile and then 100 micron 3D shape that they stacked, and then that was a part, and then they printed that part and then reconstructed the GIF backwards from all of the lased layers. So what you're looking at here is a bunch of images stitched together of each layer just after it was lased. So the light
powder. They actually printed this?
Yeah, I was trying to get.
The product must look ridiculous. It looks like nothing.
You also, like all of the parts around his face are not connected to anything, so they probably just fell out in the powder. So yes, it doesn't look like anything, but the effect is very funny. And now that this tool exists, I foresee lots and lots of these being created at kind of considerable material costs. But
it's still not cheap.
Oh, it's not cheap at all. It's not cheap. Let's see if I have another. I have one more. Do I? No, I don't. That's okay. Here are some cool examples of parts that we can print. You can print really large parts, really thin walls, overhanging structures. I can't show you obviously, but these headphones you can twist around. They're very, very ductile. Here's another good video of actually a bunch of printers printing. So the light that you can see reflected is this laser. So in reality, the laser is invisible. It's an infrared laser, but the camera that we use happens to pick up and turn the infrared into visible. But you can see it scans from the bottom to the top. And then when it's done, you'll see in the top right frame, it drops down a little bit. It actually drops down and comes back up. And then a new layer of powder is dragged over it, and the process repeats. But there are lots of things that make this really hard. As I mentioned before, this is all done at just below the melting point of nylon, which is right around 180 degrees Celsius. So this is like the temperature of your oven at almost 400 degrees. It's very hot. It's filled with this fine powder. So many things that would typically be pretty easy mechanical systems or electrical or optoelectrical systems are very challenging because because the system is so hot. So I like to joke that the two challenges in designing an SLS printer are keeping some things as thermally uniform as possible. So the top of this layer of powder here, the temperature at which it works is very, very narrow, the temperature range. So if it's a little hotter over here than it is over there, your print will fail. So you have to keep this very thermally uniform, but at the same time, you have to keep things inside the machine very hot and things outside very cool, because we have some precision optical components right outside that scan the laser that need to stay basically at room temperature. So it's the problem of keeping some things really hot and the same temperature, and things that are very close to each other, very different temperatures.
Meanwhile, all the movements have to be super precise.
Yeah. I never worked on anything that was a heated system before, and there's none of that in FIRST, but there's a lot of really interesting challenges. And like I said, I've been working on this for 5 years now. I'm gonna stop sharing my screen and just figure out how. And right now we're sort of in the thick of NPI, which is new product introduction. We are building our first units in China, and typically I would be in China with a team of engineers working with our contract manufacturer there to take what is a design that we believe will work and design a manufacturing line and work out all of the bugs associated with making lots and lots of these. But originally, we weren't sending people to China because we thought it was a health risk to our employees, and now the Chinese government won't let anyone from the United States into China. So we've been doing this all remote. I am on the phone with China every 12 hours. Which is truthfully pretty exhausting, but it's interesting. I'm disappointed that I can't be there, but imagine taking your first robot and then having to make such detailed instructions that people who speak a different language could make 40 of them every single week, and that they'd all be exactly the same and work really well. Is sort of the challenge we're facing, and it's a unique engineering challenge. It's very different from just solving a problem once.
Yeah,
so that's what I'm doing. My role in the team has sort of changed. Originally, I was an R&D engineer, so I was solving some of the sort of fundamental technology problems here. How do we heat things up? What electronics do we need? How do we design the system mechanically? Now my title is engineering program manager. What that means in practice is that I'm doing a lot of leading of this cross-functional team in what things we should be doing when, how do we prioritize, how do we create the list of all the engineering work that we need to do to hit our goal as a team. It's a 40-person engineering team. And then how do we execute those thousands of tasks and make good decisions. I actually work with Ian Ferguson, who is Tom Ferguson's son. He is my boss. He leads the whole SLS division at Formlabs, and I am the program manager on this part of it. But it's a lot of fun. It's a lot of hard engineering problems, and in a lot of ways it feels like FIRST, but stretched over many years, with challenges that you can get really, really deep into. Some of the problems here we've been working on for the full 5 years and still have progress to make.
And Ian was actually president of the team back in 2005.
Yeah, he was.
And I find it interesting, like you said, your coworker, Joe Johnson, he's an FRC mentor who's, those who are active on Chief Delphi, he's one of the big Chief Delphi people.
Is he active on Chief Delphi? I haven't been on Chief Delphi.
He at least was back when I checked Chief Delphi frequently. He was one of the top mentors in FIRST, for sure.
He was also one of the founding mentors of the team Chief Delphi back in, he's been in FIRST since the 90s.
Right.
He's a great dude.
I think he helped develop the website, which is why he was so. I think that might have been so. I'm not sure.
He's been developing a swerve drive at Formlabs. Actually, there are parts of it around.
But are there a lot of people from FIRST in your company? Do you think?
Yeah, we've got a few 694 alums. We have had more 694 alums. We've got a lot of people that did FIRST. I almost don't even know the list because there's so many of them. There's a lot.
Yeah, I think that
our CEO did FIRST, and he knows Ian through FIRST. That's how he met Ian Ferguson first, and that's how Ian came to Formlabs. And obviously, it's how I came to Formlabs. Joanna Poe worked there at one point. Sam Legion.
Pockets.
I think that might be it. Pockets, yeah.
I think people who are involved in FIRST tend to look for people who were on FIRST teams in some capacity when they're hiring, because there's just like a workflow that goes with that, like an understanding. I think.
Yeah, and I'll say, I know a lot of people that were in FIRST, and they're in all sorts of different types of jobs, all over the place. hardcore engineering, some people that don't do anything related to that, but it's all across the board. I always like when I see that on someone's resume.
Yeah. Last question for you, because we've been going for almost 3 hours. You've beaten Stephen Lamb's record.
Yeah. I could keep going, Joe. I'm talking like you for hours.
What advice would you give to younger members of the team, people in leadership role, who are on the team right now? Some of them for the first time.
That's a good question. You wrote this down. I thought about it. It's a hard question to answer. I'm gonna give you an anecdote that may or may not lead to an answer, but I remember the first meeting that I ran on 694, and it was because Stephen had the flu. And I don't know if you remember this, but a lot of people got some, I guess this is bad time some really bad flu, the 2008 season. For years afterwards, I could, if it was cold outside, it would whistle when I exhaled. I'm over this. Doesn't happen anymore. It's good news. But Stephen was out, and I was there. It was before I got whatever it was, and I was supposed to run the meeting because I was the vice president of engineering. I'd never done this before. I'd never run a meeting before, and I was absolutely terrified. I'm standing up there in front of the team, saying nothing, just frozen. And Cologne's like, "You're not doing a good job. Run the meeting. You're not doing a good job." And I was like, "I know I'm not doing a good job." I'm not sure if this leads to a piece of advice, but all of the things you do are going to be uncomfortable at first. I still do things I'm uncomfortable with. And I think learning how to be okay with doing things that are uncomfortable and outside of your comfort zone is the most valuable thing, and seeking those things out, even though it feels terrible and uncomfortable, is I think a really, really good way to grow. And it's something, even still feel uncomfortable doing it, but I search out things that make me feel uncomfortable, because it's typically the way that you learn the most. And I'd say the flip side of that is that, and I mentioned this earlier, but if you're doing something that you don't enjoy the day to day of, I mean, to be blunt, when I started this company with a friend of mine, I really wanted to be a startup founder. I wanted to make this successful company that's going to make a lot of money, and the goal was really appealing to me. But actually, a lot of the day-to-day work was really miserable because I was writing firmware, and I don't want to be a firmware engineer. It's not what I love. It's not what I'm good at. And when I moved to Forum Labs, what I was doing every day was something I was really excited about and engaged in. And the work I did was better. I made a lot more progress, and I was just much happier. So I think finding the thing that you really, really like doing every day is super valuable. It's not easy to do. And it's not you find the answer and then you just got it, but it's something that I keep in mind. And I've definitely passed up opportunities that are probably on paper, steps up, or maybe, paths to more money or whatever, that I've not taken, and I would have 6 years ago, because I know I won't actually enjoy doing them every day.
Figure out what you love to do, and then figure out how to make money doing it.
Yeah. It's not easy. I wish it wasn't that way, but soon you'll have rent bills and you'll know what I mean.
Yeah, for sure. Okay.
Yeah, I don't know. First goes by really fast. I mean, it's wild to me that it's 2020. I graduated in 2010, and it's gone by really fast. So make the most of it and go back and mentor more than I did, because it's been almost 10 years now since I moved out of New York City, and I mentored a team in St. Louis a little bit, not a ton, but I would love to move back to New York City. I would love to mentor. It would be a lot of fun. But I have a product to ship right now, so that's sort of top of my mind. Someday. Yeah. My parents would be very happy.
Yeah. Well, I'm gonna let you go, Seth. Thanks for coming on to this. Yeah,
dude, this was fun. I'd be happy to do 2010 also. It'll probably be shorter because I won't ramble about all these other things more. I guess my final note is I am on the StuyPulse Slack channel. Nobody ever messages me because they probably don't know I'm there. But if you have any questions about Forum Labs, 3D printers, MIT, I'll try to answer them. I just have one person's opinion, but yeah, be happy to talk.
Thanks.
I do read the messages sometimes and the emails, so I'm around.
Good to know. I want to say, as we sign off, I always personally appreciate that you and some of the other alumni always watch when we're competing. And like, I will have no idea you're watching and just text me like, oh, that was a rough one. I'm like, what? Or like when we went to Einstein and you and Stephen Lamb were just like texting me like, oh my God, this is incredible. That was awesome.
I'll tell you a very brief story about that. So I lived with Stephen Lamb for a couple years, and we were watching you guys on Einstein, like really, watching the screen. And when you lost eventually, like we were really disappointed, sad. So we went outside, me and one other guy who was watching as well, not a Stuy alum, went out to hang out on our little tiny balcony we had. And Stephen fell asleep on the couch, and me and Baker, who's this other guy, we got locked out on the balcony and could not raise Stephen from the dead. He was just fast asleep. So we had to climb down the side of our building to get back into our house because Stephen Lamb wouldn't wake up after watching that match. There's no takeaway from that story other than
sounds like Stephen.
It sounds like Stephen, right?
Okay. Thanks, Seth.
Cool. Thanks, Joe. This was fun. And
right.
Gene and Howard for listening to me rant for like, I don't know, almost 3 hours.
All right, we'll see you next week for hopefully 2010. See if we can organize that.
Yeah, or you can switch it up and come back to